Let me go live. Hello. 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 Not audible. I should be audible. Hello. Yes, I am audible.
But it's a different link. People don't have this link.
You have to share. I will do something. Okay. Yes, people are connecting with me. Okay, people are connecting with me. You can share this. Okay, give me a second. You can share this link. Ankit, you can share this link to all the WhatsApp people. Now, it's good. Okay. Okay, can you hear me, guys? Can you hear me? Okay, you are able to hear me. Earlier we were getting problems while connecting through YouTube. Okay, Ravi Kumar ji is here. Okay, Rishabh is here. Okay, Arjun is also here. Vijay, yes, you can now you can hear me. Say yes in the chat if you can hear me. Yes in the chat if you can hear me. Then we can straightforward start our streaming. Okay, Shubham is here. Earlier we were receiving some problems with audio and video YouTube settings. So we have generated a new link for this webinar. My team has shared the webinar link on the WhatsApp. Okay. Okay. Yes, hello. Akbul, hello. Rohit, hello. Yes, MR, good morning. Yes, people are coming. Anurag. Yes, if you are able to hear me now, say yes in the chat so we can start our streaming. Okay, people are able to hear me. Are you able to see me? Okay. CRG is also here. Like most of the people have shifted to the new link. Okay. Yes. Now people are active. Now we can start our streaming service. Okay. So let me reduce the size and we can now. Okay. First of all, yes. Many people have joined. Now we can start it. Okay, once I minimize, okay, I will be taking the doubts at the end of this section. Okay, so first we will be going through the entire webinar section and then at the end we will start. Okay, yes, people are saying they are able to hear my voice. Okay, Vinod is also connected. Okay, let's start the webinar. Let me give you a quick overview. Okay, today we are going to learn about dynamic earthquake forces and its methods, especially response spectrum analysis method and time history analysis method. And we will be going through Turkey earthquake first. Okay, we will be going through Turkey earthquake. We are going to study the Turkey earthquake why it happened and what are the reasons and what we faced, and we will look for what are the main reasons why it failed. Okay, I'll be discussing more about soft stories. If you see here, we'll be discussing about soft stories. Many of people which failed in Turkey earthquake were having soft stories. We will have a detailed discussion of soft stories, and we will see how we can detect in softwares. And we will see what most people are doing, what most people are making mistakes in performing the soft story analysis in Etabs. 99% are doing wrong analysis and they're getting wrong results from that. Okay, we will also see how to retrofit this. Okay, if there is an existing building and there is a soft story, then we will see how we can repair it, how we can retrofit it. Then we will see what is the current state of India. What is happening in India as per the earthquake, what Indian tectonic plate is doing right now. Okay, then we will shift towards the earthquake analysis method. The main concept, the main focus of this webinar is to give you the core concepts related to dynamic analysis methods. Okay, why you should do dynamic analysis, why response spectrum, what is the difference in the results of equivalent static method or time history method, that we should consider, that we should see which are different from equivalent static method. Okay, what response spectrum analysis method is giving results which are very different from earthquake analysis method. Okay, so we'll be seeing the results difference. Okay, we'll be comparing through the Excel sheet. I've already done it, so we'll be given the direct result for it. Okay, we will be doing the response spectrum analysis as well. We'll go through the physical model. Okay, this is the Etabs model that you are able to see. We will see the results of this model. So this is the actual building that has been constructed on field. Okay, so these are the results that we are going to see. We will focus on time history analysis method as well, the core concepts, and at the end we will see the results. We will compare the results of equivalent static method, response spectrum method, and time history method as well. And at the end I will discuss the doubt sessions. Okay, excuse me, let's start the 1 hour. Okay, Naib is asking 1 hour, mostly it will take 1 hour. Okay, yes, we can start it. Okay, let's start. Okay, the most common mentality of Indian people or designers or your clients, as I have designed for many clients throughout my engineering career, the most mentality that they are sharing is that you should not design for earthquake or wind forces. Okay, the client, the main purpose, the main thought process of client is that put as much as steel it can so survive the building. Okay, so we as an engineer are forced to provide less steel in the structure. So what nowadays Indian design engineers are doing is that, what are they saying? I am happy with dead load and live loads only. I have seen many young engineers who are forced by the clients to not provide higher demand of earthquake, not design buildings through earthquake forces. So they are not analyzing the building for earthquake forces or wind forces. So this is resulting in less demand of steel. The client is happy, the engineer is receiving the money, the engineer is happy, there is a cycle going on. Okay, so what engineer is saying, I'm happy with dead load and live loads only. My client is also happy with less steel. So the general consensus, when you tell your client that you want to design the building for earthquake or wind forces, then the general consensus is kuch nahi hota. Nothing is going to happen. Earthquake altogether is a myth. हमारी लाइफ टाइम में तो नहीं आएगा सर, अर्थक्वेक आता ही नहीं है यहाँ पे, अर्थक्वेक का कोई सेंस ही नहीं सर, यहाँ आता ही नहीं, ये तो जोन 2 है, ये तो जोन 3 है. So we will see later on the history of earthquakes in India. So you will see it has been a time from 2001. We haven't received the earthquake forces in India. Majorly in India. We have received in Nepal, but not in India. So people do not have a history in mind, what it can be if it happens, and how their structure are going to respond, are their structure going to survive the earthquake or not. So there is a saying, engineer client razi to kya karega kazi. But for Turkey it didn't went well. The engineer and client in Turkey were very well razi and thought that nothing will happen with them. So let's see what happened to these people in Turkey. You can see majority of buildings which were designed poorly, which are having soft story, the material that they used all together resulted in a deadly earthquake. You can see layer of story forces, layer of stories lying on one another. There is no chance that you can extract people from this bottom layer. Only from the top layer people will be extracted. Okay, here you can see it is working on. There is a very least chance that people from these layers can be extracted. They are already dead. Here you can see vast destruction that took place in Turkey. None of the people, most of the people in Turkey were not designing structures for earthquake. They were using very low grade quality of material. They were not taking permissions to build higher floors on the existing building. The existing building was not designed for taking loads from additional stories that they are building. There were many soft stories lying. In this photo you can see layer by layer. This is ground floor, first floor, second floor, third, fourth, fifth, sixth, seventh. And this is like water tank. How you are going to extract people from this? Only the top floor or the middle, the top floor of the terrace you can extract people. Here you can see they are searching for people, if they can hear anything. So if anybody is taking earthquake forces lightly, then this is your future. We will come to the India part, then you will realize that this is not a joke in India as well. If you are ignoring that this is a Turkey, sir, it is an active area, so we can ignore it, sir. There is no chance that India will receive earthquake of this magnitude. But you are forgetting that you are sitting on a Himalayan range that is formed due to earthquakes, many earthquakes, devastating earthquakes, and that region is still active. We will deep dive into that, okay, later on. So if you're thinking India will not receive earthquake like Turkey, then you are living in a myth. It is just a matter of time. It is a ticking bomb. The entire Indian Himalayan region is a ticking bomb. We will discuss more about it. So this building was not properly designed. Mostly I would recommend that they will be having a soft story at bottom. By looking at the construction material also we can see that the quality of material is not that good. And at the behind you can see the buildings which were well designed, well maintained, quality materials were used. It was designed for earthquake and wind forces. They are still standing. They are still standing. Okay, let's see this building as well. Half of the building collided. Half of the building collided. Yes, we'll be talking about Bhuj earthquake as well, Arnab. Okay, we'll be talking about Bhuj earthquake as well. Yeah, I will be talking about Uttarakhand condition as well. Okay, I will be talking about the entire North Indian condition. The South people, any students from South, you are mostly safe. Okay, the North Indian people, the entire North India, the middle part of the India, the Gujarat area still is active. Okay. Okay. So how other buildings are still standing firmly? If you are designing your building for dynamic earthquake forces, if you are not placing any soft story at the ground floor, if you are providing good materials, good design, ductile design, I have talked about a lot, and we have performed manual calculations as well on the ductile design for these projects. We will talk about this later on. Okay, if you are designing your building for ductile behavior, for dynamic forces, and if you understand the results that you will get, if you are able to analyze the results, use that results in your favor, then these buildings will be standing, no matter how hard the earthquake will be, as per the region demand. Yeah, the northeast. Vilash, we will be talking about the northeast India in just a few seconds. Okay, here you can see the half part of the building just collided, and there is no chance that we can extract these people from ground floor, first, second, third, fourth floors. The half part of the building might have, you can see there is a half part of story. Okay, there is a half soft story and half hard story. There might be several reasons why this building survived, half part survived and the half part demolished. But the main reason would be it wasn't designed for dynamic earthquake forces, and mostly the problem is with the soft story. Soft story is a killer. Okay, I have talked about it in our advanced courses as well. Now here you can see the buildings which were properly designed, even the buildings which were having a ductile reinforcement in them, they survived. Rest of the buildings which were not designed, they were poorly materialized, they collided. And you can see the smokes coming from behind as well. There is no chance that you can save people from this. Okay, let's study the data about the Turkey earthquake. Basically, this earthquake appeared at the border of Turkey and Syria. Okay, mostly in the Turkey side border. The first earthquake that took place was on 6th February 2023. It is very recent. 50,000 people died. 50,000 is not a small number. These people can be at higher positions. These people can be security people. These people can be ministers. These people can be normal people. The country is losing a lot of people, very high qualified people, which will take a lot of time to recover. So, earthquake of magnitude 7 or 8 or higher, it is devastating for a country. So I'm scared for India as well. I've seen the data. Many of the researchers are also predicting that India will receive earthquake in the northern region. So we will see how we can prepare ourselves, the older buildings as well in this webinar. Okay, the first earthquake, where the Turkey went unlucky is that, if we see in the next slide, the first earthquake that appeared was around the border, which was having a magnitude of 7.8. And there were many earthquakes of shorter magnitudes like 5, 4, 4.5, which took place after the main event. But what happened? Initially, most of the buildings might have survived due to their ductility or whatever the reasons might be. They survived the first earthquake. But in the same day, they received a second earthquake of 7.5 magnitude. Already the building has entered in the crack stage from the first earthquake. Already it is cracked. And now it received a second earthquake of very comparable 7.8 and 7.5. That was devastating. This is where the Turkey went unlucky. Any country, for any building, most of the buildings that are designed normally for equivalent static earthquake forces, they won't be able to survive 2 to 3 earthquake forces. Okay? 2 to 3 earthquake forces. So this is where the Turkey went unlucky. And there were many earthquakes after this second event as well, of magnitude 5, 4.5, 4, that later on killed many buildings. Many buildings demolished because of this second event and the last few earthquakes that took place for the entire day. There is a Hindi muhavra कि सांस लेने का मौका नहीं मिला. That is what happened with the Turkey people. एक earthquake से संभले, उससे पहले दूसरा हो गया, and then there were many minor earthquakes that shattered the buildings. Even Few of the buildings survived, but they could not survive the later on earthquake forces. Okay, let's see what happened. What was the reason for this earthquake? Here you can see these are the first and the second earthquake that took place. There is a fault line. There is a major fault line around the border of the Turkey and Syria. It is advisable, it is recommended that if you are building in a very important structure like Parliament House of the country or any grid house which is very important for electricity, any dam, any hospitals which will cater a lot of people, any important national building, or even a building higher than G+3 or 4, you should avoid the area near fault line. Unfortunately, these people did not avoid the fault line, as well as they were not designing the buildings as per earthquake demand for dynamic earthquake forces. So most of the region suffered a lot. Okay, the entire this eastern plate and this block slided. There was a sliding event that took place. A lot of energy was released that was absorbed by the building, that resulted in demolition. So let's see what happened. Now, mostly you will see that from our practical experience, the low-rise buildings like G+3, G+5, G+6, 7, these buildings are designed poorly. These buildings are not designed for dynamic earthquake forces. The time period of this building, if you can see in this graph, the time period of this building is lower than 0.5. So majority of higher earthquake forces act on them. Low quality material, not designed as per dynamic forces, and they are receiving higher earthquake forces, results in demolishing of this building. Here you can see the rebar qualities are not up to mark. Okay, most of the buildings, the older buildings in Turkey, were not using HYSD bar. They were using normal bars which were not having corrugated shapes on them. They were simple bars, smooth simple bars. So the bonding effect was not taking place between concrete and steel. So there was a higher chance that these buildings will fall, and they fell in the earthquake. At the behind you can see there are high-rise buildings which were properly designed for earthquake forces, dynamic forces, and proper site quality control was maintained. Nothing happened to these buildings. This is the best example why a design engineer is needed, why a design engineer need to design these buildings as per earthquake forces, as per the IS codes which are demanding. Okay. Now let's see what was the main reason why it fell. Mostly you will see in India and abroad as well, mostly in Turkey as well, it was seen that the ground floor of the building was provided for a shopping complex, shopping shops, or parking area. This is a very common. Okay, Weber. Plinth area. Okay, plinth height, it does not depend. Okay, you can take even a 3-foot plinth height or a 5-foot plinth height or even a 1-foot plinth height. It will not affect the earthquake. You have to design as per the earthquake force demands. Okay, class is asking TMT bars. Always TMT bars. I have talked a lot about TMT bars and the bars we are using on site, 550D TMT bars, the making process of it. So a lot of things has been talked about in the advanced courses. We will talk about it later on. So make it a habit to use TMT bar 550D on all the sites. Okay, I've seen a recent shift in the steel bar shops as well. They are not keeping bars below 500, and mostly they are advising people to go for 550 bars. Okay, so make it a habit to always use TMT 550 or 500 bars for your building design. More will be talked about in the advanced courses. Okay. Okay. The soft story. What is the soft story that I'm talking about? This. In India, you will also see mostly all over India or Turkey. Mostly Turkey was suffering from this, and there is a shopping complex, shops, parking area for like G plus 12, G plus 15 buildings. Most of the builder are providing parking at the ground floor. And from first and second floor, you will see all the walls, architectural plans, all the proper loads, walls, partition walls are laid. So the ground floor is a hollow, and the first, second, third floor have a huge mass on it. Okay. So let's see a physical example. Okay, Ujjwal 600 and 650D are also on the market. Yes, they are on the market, but they are expensive on the side. For normal projects up to G plus 15 or G plus 20, you can go with the TMT 550D. Okay, 600 and 650D can be used for high-rise buildings, G plus 25, 30, 40, 50. Okay, I have talked a lot about why you should go from 500 to 550 or 550D in my advanced courses. Okay, let's see this video. Give your full attention to this video. We will talk about the soft story in it. This is a Turkey video, okay? This is the actual Turkey earthquake video. Here you can see this is a semi-high-rise building which is having a shopping complex or many shops at the ground floor. So this means this is a hollow one. Mainly the commercial spaces are not provided with partition walls. They are only having large open spaces with large span columns. Okay, so they are acting lighter. If you can see, the entire structure from first floor to above floors is like a inverted pendulum. The huge mass is lying above the ground floor, and there is a thin strip that is holding, that is with ground floor. If earthquake happens, the large mass is above the ground floor. The entire forces that have to take place through the ground floor columns will receive massive forces due to this soft story effect, and they won't be able to survive. This is what happening with this building. Let's see. Went away. Here you can see it started falling. This is the same building. The ground floor crumbled. The above floor is intact. The ground floor crumbled, and then the entire building crumbled. Let me show you again. These are people, these are actual people who are walking away from building. There are many people still inside this building. Again, the soft story started falling. Yes, it started falling due to soft story, and the entire building collapsed. This is a progressible collapse. So in many events you will see that if a building is having a soft story and it is designed properly for first, second or above floors, then part of the story might fall due to soft story and the above story will survive. And if the entire building is weakly designed, it is not designed for earthquake forces, then there will be a progressible collapse. First the ground floor will collapse, and then progressively the first, second, third, fourth floors will collapse. Okay, so this is what you have to see. There is a progressible collapse. Okay, so you can see the actual people are running from this earthquake event. So this is not a joke. Many of people died, and whosoever is taking lightly that earthquake forces are nothing, it's just some myth, then you can see these videos. Many people died, many families destroyed. This is what I am talking about. If the building is designed properly and there is a soft story. This is also a Turkey earthquake before and after photo. Here you can see there are a lot of coaching institutes or any shop kind of a thing for ground and first floor. There is a hollowness, and from this Second, third, fourth floor, you can see dense, compact, filled with partition walls, furnitures. The entire mass of the building is concentrated above the ground floor. So what happened? Majority of it was well designed for above the floors, above the ground floors. So upper part survived and the lower stories collapsed. The people who were in the ground floor or the first floor, second, third, they died. And the worst part about this is there is a huge mass lying after the earthquake event. You will not be able to approach the people which are inside this building. So why I'm discussing this top story in this webinar is that India is suffering heavily from this problem. The population of Delhi is around 3.2 crore. And you will see most of the buildings, semi-high rise or G plus 15, G plus 20, even G plus 20 are having either parking or they are having commercial spaces or they are putting clubhouse at the ground floor. All these are a part of the soft story. Commercial spaces, shops, parking, and no matter how hard or how strongly you design the upper part of this building, you put all the steel into the upper part of the building, but if you are having a soft story at the bottom, the building will not survive. The upper part might survive, but the bottom, the ground floor, first floor will not survive. So it was useless to design this building as per earthquake dynamic forces, as there was a soft story lying at the bottom floor. So it's a very important learning for young design engineers. No matter what hard or how much steel you provide to the upper floors, if there is a soft story at the bottom floor, the building will not survive. This is 100%. It won't survive. And now you can see this building is useless. What we will do with these upper floors? Nothing. It has to be demolished. It has to be demolished. Okay. We have to demolish this part. It has been no use. Let's see. This is an example of Bhuj earthquake, 2001, Kutch area. The building was under construction. Okay, here you can see the first floor, second, third, fourth were having some partition walls. It was slightly denser than the ground floor. The ground floor was entirely empty. It was a hollow part. Here you can see still the framing, the material crane is still attached to this building. The entire ground floor, the entire building slided to the right, and it entirely destroyed it. This building is of no use for us now. So no matter how much steel you put to the first to top floors, if there is a soft story at the ground floor or at the first floor, I've seen many builders and many architects and design engineers, even for buildings for G plus 15 or G plus 20, they are putting parking at ground floor, first floor, third floor. There are multi-level of parkings at ground, first, third. This is a severe effect of soft story. No matter how perfectly, accurately, for all the dynamic forces that you can think about, if you design that building, it won't survive. The whole force of this dense mass is acting on these thin columns. It won't survive. There is no chance it will survive. Okay, Cobbing is saying we should provide shear walls or brick walls preventing soft story in hollow GF. Yes. If it is possible, you should provide some amount of shear walls at the key locations. Like I understand you need to provide a parking at the ground floor, but at the key locations you can provide shear walls. At the key location you can block the buildings, block the openings through brick walls. In a few moments we will see how we can retrofit the existing buildings as well. Okay. No, Kailash, soft story cannot be provided on the top floors as well. Okay, we'll be discussing what is the soft story. Okay, soft story cannot be avoided in many cases, especially in houses, construction of slope or hills. So we will increase the, okay. In that case, in a slopey hill, it cannot be avoided. For that, in that case, you have to provide shear walls, or you have to provide X brace, V brace, K brace, so that the hollowness is filled with strong diagonal elements that will resist the earthquake forces. Okay. No, Chris Roy, if you increase the column dimension, for how long, for how much thickness you will provide the column dimensions, okay? Column cannot handle that huge mass that is lying on the top of the building, on the top of the ground floor or first floor. Columns will not be able to handle that forces, even if you increase the thickness by 1.5 times or 2 times. The ultimate thing is that you have to place shear walls or fill with X braces, K braces at the proper location. You have to place that at proper locations. Okay. Echo, if you are talking about getting certificates, you can contact the support team. They will provide your certificates as well. Many of mega course students have got their certificate. They have cleared the test and they have got their certificates. These are ISO certified certificates. Okay. So Echo, if you are talking about certificate, contact support@fieldready.co.in. That same team is providing the doubt support as well. Okay, on daily basis we are providing doubt support to the students as well. So do come in contact with the support team. Okay, this was a Bhuj earthquake. Now this is the situation of India as well. The ground floor is a parking. There is a soft story, so it won't survive. No matter how perfectly you design for earthquake forces, this won't survive. This is a very common building type that you will see in India. Ground floor parking, ground floor shops, first floor densely placed with stones, bricks, partition walls, second floor and the third half floor. Here you can see how thin the columns are. The hollowness will kill this building. This is a corner plot, corner building. Corner buildings are even at a worse situation for earthquake forces, because they are providing opening for both the faces, like it's east side or it's north side. The entire left and right side is open, it's hollow. This building will not survive in the event of earthquake forces if it is lying in third, fourth or fifth zone. The same thing happened to this green building. The top floor survived and the bottom floor didn't survive. Now this building is a useless building. Demolish it. रद्दी के भाव बिकने वाली बिल्डिंग हो गई. Okay, so if proper attention was given to the soft story, the ground floor of this building, then it would have survived. Nothing would have happened to this building. Okay, let's see main building. This is a G+12 story building. The water tank is lying on the top of it. It has been designed in the Etabs software. Okay. Now, here is what most people do, what most design engineers do. They design this building as a hollow frame, total frame without infills. This is the common practice that we design engineers, civil engineers, structural engineers are designing buildings in structural softwares. We are not placing walls. We are just placing columns, beam, the entire 3D portal frame, staircase, water tank we are placing, but we are not placing walls. We are designing the buildings without infill. But in actual practice, the entire building will receive walls above the ground floor. Here you can see the ground floor is the parking, this is the bottom, this is below the ground floor, going to the foundation level. Okay, this is the ground floor, and above the ground floor the entire area will be occupied by the occupants. Here you can see this building is having 6 flats at each floor level. 1 flat, 2, 3, 4, 5 and 6. This is the common area. It is having at least 250 to 300 people in it. Okay, it has been actually constructed on site. We have taken a practical example. Okay, you will be learning the entire how to design this complex shape building in advanced mega courses. So in actual practice, you will be placing walls in the building. So you should, if you want to check soft story, if there is a existence of soft story in your building, then you have to place walls. If you are not placing walls like this, see, most of the engineers, most of the novice engineers, most of the YouTube, if you learn from the YouTube, you will see they're not placing walls. If there is a building of G+1, G+2, then it's okay, but this is a building G+12. The soft story effect will be very prominent. To make it a habit to place walls if you want to check the soft story effect. Now if we see by definition what soft story is meant, that if the stiffness of the bottom story is lower than the top story, then there is a soft story. If the stiffness of the ground floor, the bottom story, is lower than the top story, then there is the existence of soft story. Here you can see if we design the building through normal portal frame without placing any walls, then the ground floor, the bottom plinth level and the ground floor, first floor, second floor, all are having higher stiffness. Ground floor stiffness is higher than G+1, then G+2 has lower stiffness, G+2 has higher stiffness than G+3, 4 and so on. This is a safe building as per in the software. But in actual practice, if you place walls, then what software is resulting to you is that the ground floor stiffness is lower than the first story, second story and above stories. So the entire structure above the ground floor, this entire structure above the ground floor is having a very high stiffness as compared to this ground floor, even the first floor. Some part of soft story effect is transferred to the first floor as well, even if you place walls. Okay, so the nearby stories also suffer if there is a hollowness or soft story at the ground floor. The entire top part of this is having higher stiffness. So if you are designing your buildings for this empty portal frame, then you are mistaken. Most of the design engineers are making this mistake. If you are serious about soft story, you should be serious about soft story, then you should design your building by placing walls. I've explained the entire process in the advanced courses. Okay, you have to consider the strength part of the walls as well. Okay, Praveen, yes, I have seen many of the design engineers are only considering equivalent static forces, but in few seconds you will see why we should never touch equivalent static forces after this webinar. I will recommend you should not even touch or apply equivalent static forces in design softwares. You should straight or forward go for either response spectrum analysis or time history analysis. Okay, in few seconds you will see. As I am a practicing engineer, I see a lot of flaws on site, a lot of flaws in the mentality of the client, the builder, the contractor. But as a design engineer, I know at the time of earthquake, these buildings will not survive. The clients are saving like 2 to 3 lakhs, 5 lakhs per building by providing low steel. But the entire family of him will die in the event of earthquake. So give it a thought, like what is the cost of your family member? 1 lakh, 2 lakh, what is the cost? There is no cost. No price can be put there. So it is better to prevent your building from falling by providing by doing proper dynamic analysis earthquake forces, and rather than just providing simple dead load live load earthquake forces, and that will fail. Yeah, very good afternoon. Can be shorter column size for sub-story stability. Yeah, this is a jugaad, Akshay. Akshay, this is jugaad. Okay. You can be shorter column size for sub-story stability. Okay, no, we cannot short. This is only a jugaad. You have to provide proper shear walls or X braces, V braces, K braces. Okay, this is what you have to do. Okay, Akram Ali. If you are talking about the mass participations and the first mode, second mode, third mode, model analysis basically, we will talk more about it. Okay, I have talked in detail about the model forces, first mode, second mode, third mode. Even if your first mode is a rotation mode, you can work around it. Okay, for the buildings like complex shapes like this is evident that you will receive first mode as rotation mode. Okay, if I show you the first mode as rotation mode, this is the rotation mode. The first mode is a rotation mode because there is eccentricity between the center of mass and center of rigidity due to this very complex shape. The first mode is a rotation mode. So most of the engineers, novice engineers, amateur engineers, or most of the YouTubers would say you to that you should avoid, or you should never place a first mode as a rotation mode. But as a practical engineer, let me share with you, you will not be able to avoid it. You will be able to reduce it, the amount of rotation, but you will not be able to avoid it. I have talked more about this rotation modes in the advanced courses. Okay, let's back to our soft story. Okay, so make it a habit from now onwards to place, if you want to check the building for soft story effect, then you have to place walls, okay, in the analysis model itself. Then only you will be able to get these results which will shaken up your eyes that your ground floor and first floor is a soft story. In the courses we will learn how to prevent this soft story effect. Now, if the building is already constructed, like majority part of North Indian buildings, they are already constructed, parking is present at the ground floor. So how we can prevent this soft story effect? You can place steel frames on the opening side of it. These steel frames will handle the sway effect of this ground floor story. Okay, these steel frames will prevent this inverted V K brace. Inverted V and K braces if you can place, and if you can see the balcony side is also supported by some amount of steel obstructions outside. So if there is an existing building, if you want to prevent it from falling, there is a soft story, then you have to do this retrofitting. Retrofitting is very important. Without retrofitting, these buildings will not survive. There is no chance that these buildings will survive. So this is how we retrofit this existing buildings, by placing steel braces. Okay, this is how we are going to prevent this soft story effect. So the entire North India part, the majority part of India are having soft story at the ground floor. So this is how you can retrofit these buildings. So it is a must to retrofit these buildings. Okay, now what if there was an existing walls which were placed at the ground floor? You are not constructing the flats at the ground first, second, third floors, but there are existing walls. This is the actual picture of Turkey building. Okay, a building existing in Turkey which were having walls at the ground floor. Here you can see through the extensive shaking, the entire ground floor walls has broken. There are many shear cracks as well, but this building survived. Some part of the effect was transferred to the first floor as well. You can see the cracks as well. But mostly this building survived. What if there was no walls on these side of the buildings? You can see left and right, both faces are having walls at the outer side. This is, so the entire energy was absorbed by these walls by going under shear cracks, falling apart, breaking. The entire energy was absorbed by these walls. So the entire this building survived. Otherwise, this could have been a soft story failure with progressive floors falling one on the other. Okay, one on another. So now you would have understand how important it is to give importance to the soft story. Okay, Pavan Kumar. If you are placing walls, this is even a myth between engineers that if you are going to place brick walls, okay, if you are going to place brick walls and the building is not going to survive, it will assist to a certain level. If your building is lying in second zone or third zone, and if you have packed your ground floors with the outer walls or the outer periphery with the brick walls, then there is a little chance of it to survive during the earthquake forces. The ideal solution is to place shear walls. The ideal solution is to place X-brace, V-brace, K-brace steel structure bonded with the column and beam portal frame at the key locations. That key locations can be identified in Etabs model. Okay, in the advanced courses you will see how we can perform the soft story analysis as well. So there is a little chance if you place brick walls, but there is no 100% surety that it will survive. If it is a 4th zone, 5th zone, or if the building is receiving 7.5, 8, 9 scale earthquake, then it won't survive. Brick wall is not the solution. Shear walls at the key locations and the K-brace steel braces, that are the solution. Let me tell you that bracing, these X braces, V braces, K braces are very, very effective in earthquake forces. They are killer of earthquake forces. Like they will eat the earthquake forces. Once you analyze the building in Etabs, you place K braces, X braces, V braces, you will realize it. Most of the New York buildings, okay, most of the New York buildings are having K braces, V braces, X braces. This is how they are defining. This is how they are defining the earthquake forces, even the wind forces. Okay, let me give you a small, more practical tip. If your building is more than G plus 20, G plus 25 or 30, what I am talking about is Mumbai buildings, Delhi buildings. You will see majority of high-rise buildings are first in Mumbai, then in Delhi, and the third one in Bangalore, and then other parts of this country. So those buildings are more concerned about wind forces rather than earthquake forces. Okay, I will be conducting a very practical dynamic wind force webinar as well, which will be applying actual wind forces, wind flowing on the building, and you will be collecting the data from that virtual wind tunnel test. Okay, I have included that part in the advanced courses as well, but in the future webinar, maybe within next month, we will be conducting that webinar as well. So alone earthquake forces will not save your building. You have to apply wind forces as well. Okay, Akhilesh will talk this about the modal mass participation factors and first mode, second modes in a bit. Okay. Now let's talk about the India. What is the situation of India? Turkey is another matter. If any family member is living in Turkey, then you can be concerned about it. But what is the actual situation of India? We are living in India. How much we should be concerned? How much we should concern our clients? What places of the India are most active? And what are the future earthquake places where we can expect that future earthquake will take place? So here you can see the Nepalian area. This is the stress strain vector diagrams that you are seeing of Indian tectonic plate. This is the entire Himalayan range, and the majorly you would have remembered in 2015 there was an earthquake in Nepal. Okay, so this is the stress strain diagram that is showing the Nepal area is still active. The entire Himalayan range is still active. There are huge stresses lying in this area, even in this eastern part. In the eastern part, you can see they are higher. There are large vector graphics that are showing there is a strain in this land area. These strains are calculated by satellite images. Okay, there are softwares which calculate the strain lying inside the building, inside the land area. Here you can see the Gujarat area, the entire Gujarat area. There is a slip plane. Okay. Here you can see the pink line. This is the actual fault line of Indian plate. Actual fault line. So along the fault line, there will always be major earthquake events taking place. The entire eastern part, here you can see. Entire eastern part. This confirms the higher vectors. This region is also very active. The entire Himalayan region is very active. The entire Gujarat region is very active. This is a marshy land. Majority of part of eastern Gujarat, western Gujarat is a marshy land. Very thulthuli land where the Kutch is lying. It is also very slippery, very active zone. Okay. Here you can also see how the Indian plate is crushing the Tibetan plate, the Chinese plate, Tibetan plates. The entire stress is around the Himalayan region and the eastern part of it. Mostly the west part is a slip lane. Okay, not most of the stress are lying on the western part, but it is a slip lane. This western part is not pushing much to the other part of the land area. If there is sudden event in this area, or there is a stress developed due to slippage, then there will be an earthquake event here, which is what happened in 2001 Bhuj earthquake. The Japan area is very active, very active, very active. So these are the modern images, satellite images, which gives us a clear idea what is the situation in India. So earlier I was saying the northern part should be very concerned about dynamic earthquake forces. Dynamic earthquake forces. So majority of population of northern India is lying along this. Delhi is here. Let me give you another idea. Okay, this is also stress strain part. Delhi is here. Lucknow, Patna, Bengal, Assam. Most of the population of Delhi is around 3.2 crore. This is not a small population. The IIT Kanpur is also lying here. The IIT Guwahati is also lying here. Majority of population is living in this area. Majority of population in this belt, and this is a highly active belt. If you are not designing buildings as per earthquake forces, then there is a certain that these buildings will fall. If there is a soft story in your building, that buildings will fall. Okay. Again, this is a stress strain vector diagram. Here you can see Japan is very active, very large vector forces, and Himalayan region is active. Himalayan and eastern region is quite active. As of now, the western part is not that active. Okay. Here again, this is a stress strain graph in a finite element analysis. Japan is very active, and the Indian part, the entire Himalayan range, the Jammu Kashmir area as well, and the eastern part. Eastern part is receiving more strain. So all of the engineers, students learning from the east part of India, you should be very active. You should be learning the advanced design courses. You should be applying dynamic earthquake forces on your building. If any client is forcing you to not to design building as per earthquake forces, you should avoid that client project. Okay, I have ignored, I have cancelled many client projects who are forcing not to apply earthquake forces to save steel, because there would be later on legal consequences. If your building will fall, the government, the local authority, municipality party, or the JDA party, development authority party, will pick you from the home if many of your buildings fall during the earthquake, which were newly designed, which were designed to handle that amount of earthquake forces. Okay. So in Turkey as well, in Turkey, the government is picking up engineers who design the new buildings which fall during the earthquake. If you're thinking it will not take part, if you're thinking that once designed nothing will happen, then you should be very much sure. You have to design the buildings as per earthquake forces. Yes, western part is not usual. Western part as of now is not active as much. Okay. At that part during the 2001 earthquake of Bhuj, it was active. The entire amount of stress, the slip plane, if you can see, the entire stress that was happening at around 2001 in Gujarat, Bhuj earthquake, was released during the earthquake. Now it is a much more of a little more stable area compared to the northern Himalayan region or the eastern region. The Himalayan region and the eastern region is still under stress that want to release. Okay. Yes, Kailash, Assam is a very active area. Assam is a very active area. Okay, in the advanced courses I have taught more about this, how you can identify the earthquake taking place in the real world scenario. As you have joined my live session, let me share this part with you. Okay, let me share this part. Seismology Department of India. All of you give attention to this part. It's a very important part. Okay, it is a very important part. Give attention to this. There is an entire national agency which is set to record the earthquake forces through several earthquake elements, several earthquake seismographs placed at the various locations of India. So you can see, as current, the red ones are the active earthquakes which took place under 24 hours. So here you can see North Garohille, Meghalaya received an earthquake of magnitude 3.2. It received an earthquake 3. The entire zone, here you can see the entire zone is very active. So the National Center of Seismology is keeping a record. These are live records that they are keeping. So what I have taught you, that the entire eastern part, the entire Himalayan region part, including Jammu and Kashmir and some part of Leh Ladakh as well, are very active, and even the eastern part is much more active. Here you can see that part is also active, which is confirmed by this eastern part, and the west part is not that active. Okay, the west part is still not that active. There's a small amount of earthquake forces taking place. 3 and 4 are negligible earthquake forces that you can ignore. Okay, so one of your problem will also resolve with this National Center of Seismology website. Some of you might not be able to see the location. You would not be able to identify the zones, earthquake zones, through the maps provided in the IS codes 1893. Here you can zoom it as much as you want to, so you can clearly identify that Rajkot is in zone 3. Okay, Rajkot is in zone 3, Morbi is in zone 4, and Bhuj is in zone 5th. So in recent, you would be remembering Morbi bridge fall in Gujarat. Many of people died. We will talk more about it later on in a future webinar. Why this Morbi bridge fall? Okay. So through this you can identify. Now you can see from Rajasthan, This Udaipur is lying in second zone. This Vadanagar, Maheshnagar, Himmatnagar is lying in third zone. You can zoom in as much as you want to. Okay, Jaipur is lying in second zone. Okay, Delhi is lying in fourth zone. 3.2 crore people are living in this Delhi zone. Very active zone. Many of fault lines are lying in this zone. Okay. Always use this map. If you are not able to identify your zones or IS code is not providing you a clear picture of it. Okay. Yes, Ujjwal, you should always design your building for dynamic earthquake forces if you are living in zone 5. There is no relief for people lying in zone 5. Okay. There is no relief for people lying in zone 5. So always use this. Let me share more details about it. How you can. Let's remove the seismic zones and fault lines. What I was talking about earlier, this is the fault line of India. This is the fault line of Indian plate. This is the most active fault line. The direction of pushing is towards this plate, this direction. Majority of earthquake forces are taking place in this direction. In recent, you would see earthquake force took place in Afghanistan. The history of that earthquake force is also here, which were felt in New Delhi and some part of Jaipur as well. Jaipur is also lying on fault lines. Okay. The Delhi is very close to this region. Lucknow is very close to this region. Patna is very close to this region. The entire east part is under zone 5. So there is no relief. You have to design earthquake. You have to design structures as per dynamic earthquake forces. Okay. Give me a second. Now let's get back to our webinar. Okay. Recently, if you look at the history of the earthquake forces received by India, the Indian plate, you will see that in we have a data for 1934, 8.1. 1934, 8.1 earthquake, magnitude of 8.1. In the 1950, around 8.4 in the eastern part. Then if you come in 1991, 6.5, 1999, 6.8. Even in history, 1905, 7.8, Jammu and Kashmir area. And this Pakistan border, India-Pakistan border, around 7.6. And in 2001, there was a 7.6 earthquake due to slippage in Bhujkark area. So the entire northern eastern part, north part, the Himalayan region still is active. And it is receiving, and this is the recent earthquake that took place in Nepal, 2015, 7.2. Devastating earthquake forces acted on Nepal. Majority of Nepal buildings were masonry buildings. So there was no chance that they will survive to handle the shear forces of dynamic earthquake forces. So the entire Indian plate is shifting by 45 to 55 mm per year. Okay, per year this building is shifting. The entire Indian plate is shifting towards the Tibetan plate. So there are huge forces which are developing. It is not stopped. This is a dynamic activity which is still going on. So you can expect future earthquake forces around these areas. Okay, around these areas. And then I have already told you, the national capital of India, New Delhi, is very close to these regions. Now, if I want to share data with you for networks, observational networks. These are the seismographs which are placed by National Center of Seismology Department of India. Major cities are having their their departments in each city of India. Majority metro cities, second tier cities are having their departments. And in Delhi, you can see a large amount of seismographs, digital seismographs has been placed. Through these seismographs, you are able to see the live event, the live earthquake forces, the live earthquake events taking place. These seismographs are recording it. Even in Port Blair, here you can see seismographs has been placed. Okay. These are the seismographs which are providing you the data. Let's shift. Okay, now what is the role of the engineer, right? Okay, we have a very huge role in building this nation. Okay, an earlier old saying was that roti kapda makan. There was three requirements of common people. Only three requirements: roti kapda makan. Makan comes under our civil engineers, structural engineers, contractors, builders. It is very important that we are 1/3 from the whole part. We are playing our role. Without an infrastructure, without very sound buildings, the country won't survive. Even the country won't exist. The best example for this is Dubai. The entire Dubai was built by civil engineers. There was no city around it, and the entire civil engineer department, civil engineers changed the landscape of the Dubai. So we have a very large role to play, and we have to play it fairly. Okay. Now let's shift to the earthquake methods. In our earlier webinars, I have also discussed about the types of earthquake methods we can apply on buildings. There is a static and there is a dynamic. By static, we already know the force will be static. It will be constant with time. So the equivalent static force method comes under it. It is considering then a fixed earthquake force will be applied on each floor. Under dynamic, we have response spectrum and time history. Again, this will be linear, non-linear. Okay, but as per IS codes, IS code is not recommending or forcing us to go for non-linear analysis, even in static case or in non-static case, dynamic forces. Okay, so for majority of cases, you should limit yourself to linear model analysis only. Okay, linear seismic analysis only. If your building is very irregular in shape, it is a very new kind of building, the columns are inclined. If you are placing several complex parts on it, then you have to definitely go with non-linear analysis. The problem with non-linear analysis will be what? You have to have the data for that non-linear part, like column beam joints, non-linear part data with you, which comes from the experiment. So for majority of part, we will be focusing on linear, not non-linear. Now we already know that equivalent static method, we apply forces. A base shear is applied on the building and it is distributed along the floor of the buildings from ground floor to top floors. And the distribution pattern follows the formula, Q formula, which is a quadratic equation. It is a parabolic equation actually. Okay, it is a parabolic equation which is following. Here you can see this is a parabolic equation. So now, how the engineers, the design research engineers came to this formula that this force distribution will be parabolic in each building, no matter how much complex the shape building is, how much complex the floor plan is, how much complex the elevation of this building is. All buildings will receive earthquake forces in parabolic form. The variation of earthquake forces will be in parabolic form. This is the first and foremost failure of equivalent static method. Actually, in few seconds you will see that the distribution of earthquake forces along the height of the building is not following the parabolic formula. It is following its own formula. Okay, the dynamic property of building is shaping the distribution of this. Here you can see in the advanced courses we have compared the methods. Okay, so we have compared the results for equivalent static method and response spectrum method. These are the floors. G plus 12 story building with water tank, and here you can see the base shear data for equivalent static method, response spectrum method, and differences. In this graph you can clearly see that the equivalent static method force is following a parabolic formula. But in actual practice, if you go for dynamic forces, you can see there is a less demand of earthquake forces for the buildings from G plus 4 to G plus 10. It is not following the parabolic formula. It is following the actual vibrational data, the model shapes that building is taking due to complex shapes. So you should avoid using equivalent static method to determine the shear forces in the entire building. Okay, you should completely avoid equivalent static method if you want to determine the actual forces experienced by a building along all the forces, along all the floors. So this results confirms that what you are thinking, that you will be designing the building for equivalent static method, you will be receiving correct data, but no. From response spectrum analysis, it is clear that the middle part of the building is receiving less base shear forces, less shear forces. So you can save a lot of amount of steel for designing this building. Okay, so this is why you should shift to dynamic force methods to determine the actual behavior of the building, the actual forces which will be acting on these buildings. Okay, acting on this building. So it's very important. We have talked a lot about it. We have formed, actually in advanced courses, we have formed this entire graph. We have taken the forces from the analysis results of Etabs. Here you can see the entire Etabs model is formed. Very complex shape. Very complex shape. Here you can see offset columns. Beams are at a very offset from these column centers. Okay, you will learn about it, how you can design these columns, beams. Okay, in the advanced courses you will learn about it. So these are the results which we got from this Etabs analysis. Okay, so from here onwards it should be very clear in your mind that why you should not go for equivalent static method and why you should prefer at least response spectrum method for your buildings. So through equivalent static method you would never be able to calculate the exact forces experienced by your floor system, by your different floors, ground floor, first floor, second, third, and so on. So if the force amount is not correct, then how the column and beam design will be accurate? Because the entire shear force will be distributed among those columns and shear walls, then it will be designed for it. Okay, so this is the reason, this is the practical reason why you should shift from equivalent static method to response spectrum method, at least response spectrum method, to design your complex shape buildings. Even for G plus 3 or G plus 4 structures, you should do that. Okay, now let's talk about the definition of response spectrum. What is this method all about? Okay, what is this method all about? Now a response spectrum is a plot of a peak or steady state response of a series of oscillations of various natural frequencies that are forced into motion by the same vibrational force. The resulting plot that can be used, for any linear system given its natural frequency of oscillation is known. Now what we are doing in this response spectrum method is that we are for example taking linear systems having variety of vibrational time period, T1, T2, T3, T4, T5, and then we are shaking those vibrational masses to same earthquake force, the same earthquake force. Okay, the ground motion data is same. So this is a dynamic part which is applied on a linear system. Then we record the peak amount of, like what was the peak response of this W1 M1 mass building. That was the peak response for second building, this was the peak response. For the third mass, this was the peak response. So if you sum up all these, like if you plot a graph which represents time period of building along x-axis and the responses of building along y-axis, then you will get a curve, a response spectrum curve, basically a curve, simple curve, response curve for these entire masses. So this is the beauty of this response spectrum method, that you're converting a dynamic problem into a pseudo problem. Basically you're converting the dynamic forces to static forces through these graphs. So it becomes very easy for softwares and the calculation people. So directly pick, like what will be the example. If your building is having a time period of W3, say 0.3 or 0.4 second, then you can directly pick the response from here, this graph, the maximum response that this building will receive in that future earthquake. So this is the beauty of this spectrum curve, which we can see here as well. What we have done for several mass systems having different time periods, 0.5, 1, 2, 1.5, 2, 3, 4, we have applied several earthquake forces, several ground motion earthquake forces, green, blue. You can see these are several actual dynamic earthquake forces which are applied on this system. Now, for simplification of calculation, the design community have converted the entire these curves into single response spectrum curve. Now this is called as response spectrum curve that you will be very familiar from the IS codes. For soft soil, medium soil, rock and hard soil, this is the curve this is how the curve arrived. This is how the IS code team arrived at this curve. The entire calculations were done from various ground motion data, and then they formulated this response curve for angel soil systems. Okay, so here you can see for response spectrum method, this is the curve that we have to follow. We can directly pick, if a building time period is like 0.5, they can directly pick the response 2.5 SA by G value. So you're converting a dynamic problem into a static problem. Okay, and the SA by G value numerically can be also calculated from these results. So keep in an eye that soft soil will always attract more earthquake forces. So this is why for even a G plus 15 or G plus 20 building, it will receive a higher SA by G value, higher spectral forces. Okay, the soft story, if your building is having a soft soil, then it will receive more forces than medium soil, then hard soil. Okay, so there is an interesting observation here as well. If somebody is designing a building, if there is a complete design results for a zone of 2, okay, earthquake zone 2, and it is having a hard soil. So many of engineers or architects or many other contractors you have seen, they pick the design sheets from an older building that has been constructed. They are not willing to give design engineers the money for designing their new buildings. They're picking the results from the older building design sheets. So what mistake they are doing is that they're picking a building design which is based on a hard soil. So in the same city, if your building is lying on a soft soil, which you will be identifying from a soil test, then that building, the same building which will be constructed on soft soil, will receive higher amount of earthquake forces. This is what this spectrum is saying to you. So if somebody is like stealing the design from you for harder soil, then they are building on a softer soil, and the contractors or architects are doing this method, then this is completely wrong. That building will fail under earthquake. So it is a good observation from this part as well. So we say in a very famous saying in Hindi is that nakal mein bhi akal chahiye. So that part is applicable here. Okay. Now you might be thinking, sir, this spectral curve is given for equivalent static method as well, and it is given for response spectrum method as well. So how response spectrum method is different from equivalent static method? We are picking up the values from this table itself, from this graph itself, then how response spectrum method is able to predict the accurate model shapes of this building. What is the key factor? What is the game changer? What is the game changer? Yes, Saurabh, you have picked up a very important question in India. Okay, Saurabh, hello sir. Why in India not any government authority is forcing structural engineers to pass the design test? It is very important. Let me give you an insider information. In Gujarat, it is a mandatory for the authority, for any contractor, architect to pass the design from a structural engineer. Structural engineer seal will be applicable on each design sheet that has to be passed by the design authority. Unfortunately, in majority of Indian cities, they are not forcing. They are not implementing this part that the seal of structural engineer is also important. We are the structural engineers which will be saving the life of these people. The architectural part is the beauty part, but the strength part is very, very important for a building that most of the people and the authorities are ignoring right now. So in the coming years, you will see that around 3 to 4 years or in around 5 years, you will see that majority of municipality corporations or development authority of your concerning areas will mandatory the seal of structural engineers, civil engineer. Without that seal, that building plan will not be passed. So it is a very important. The main person in a building design, which will be saving the life of the people, are design engineers, civil engineers, structural engineers. So if you are not making that person responsible by placing a seal on that sheet, then he will design that building with not 100% conviction. So it is very mandatory for the authorities to force these municipality corporations and design engineers to place their seals. Okay. Yeah, the member. Okay. Yeah, Ujjwal, in your area, like in the east area, it will be mandatory. But if you talk about Rajasthan, it is not mandatory. Okay. Even with a normal seal of architect, it can be passed. There is no need of structural engineer seal requirement. Okay. Many of architects will even miss the name of structural engineer that has designed that structure. Okay, Ujjwal, in your area, which is zone 5, the authority is forcing them. But in Rajasthan and majority part of India, they are not forcing to place structural engineer. Okay. Okay, Keshav will be replying to your displacement part in a few seconds. Okay. So if you are like, what will happen if you make it mandatory for structural engineers to place seals? Then first of all, you will be recognized legally in the Indian system, in the construction system. First of all, you will be reliable, and if you are reliable, you will be paid more. Okay. If the seal systems come up, then you will be paid more, and there will be less casualties as compared to the Turkey. The earthquake happened in the Turkey. There was no system at all for designing buildings in Turkey. People were not following those results. Even the municipality corporations and the development authority were not following the rules, which led to the failure of so many buildings in Turkey earthquake. Okay. Now, I was talking about, we are following the same spectral curve for equivalent static method and response spectrum method as well, with little changes. But the game changer in response spectrum analysis method is that we perform model analysis, from where we can it is a very complex problem that if you shake a building with earthquake force, then what shape this building will take during the entire shaking event. What will be the shape? What will be the shape of this building? So this complex vibrational data, the vibrational shaking of the building is calculated through model analysis. So for dynamic methods, this model analysis is a game changer. Without model analysis, none of the advanced dynamic earthquake methods can produce results which we saw in this graph. So this is the model analysis. What we do is we break the complex vibrational data of this building into simple modes. First mode, second, third, fourth mode to n number of modes. Then we superimpose the results of individual modes to come up with the complex shape modes of this building. So here you can see the simple modes is vibrated. The forces are picked from spectrum curves for different time period of these different modes. All modes will be having a different time period of shaking. So for different time period of shaking, we have already formed the spectrum curve in response spectrum method. So we will be taking those time periods, we will be applying the forces. The force vectors will be calculated and then they will be scaled up. And the final bending moment shear forces will be calculated as per the dynamic forces this building is receiving. So the entire game changer is model analysis. Without model analysis, there is no response spectrum method, there is no time history method, especially for linear time history. So we have talked about a lot in our Etabs as well. Etabs advanced courses, we have done the model analysis as well. If you see the load cases, here is the model analysis. Here is the RITS analysis. There are two types of model analysis, eigen and RITS. We have talked a lot about these methods in this as well. We applied the equivalent static earthquake forces. We have applied the response spectrum forces in X, Y and Z direction. Z direction forces has also been applied. We have applied the time history forces in both X, Y, Z directions. We have applied the wind static, wind dynamic, and we have performed the short-term deflection check, long-term deflection checks as well. Okay, so this is how, without model analysis, there is no meaning of this response spectrum forces, time history forces. Okay, there is no meaning, not at all. So this is the game changer. If you conceptually, if these questions arrive in your mind, so what is the game changer in this? Response spectrum analysis and time history equivalent static forces, both are following the same curve, almost same curve. Okay, then what is the game changer? This is the game changer. The model analysis method of eigenvector and RIT analysis method. This mathematical model is giving us the data about how the building will shake, how the shaking shape of the building will be formed. The entire vibrational data, the entire vector, displacement vectors, force vectors will be provided by this method. So for this complex shape building, it is very necessary. This building will not shake in a simple manner. This is a complex shape building, it will shake in a complex manner. So that entire complex calculations and the data will be formulated by model analysis. This is very important to focus on model analysis as well. Without model analysis, there is no dynamic force calculations. This is the soul of dynamic forces methods like response spectrum method and linear time history methods. So this was the actual practical and the most contextual part that I wanted to share with you, that do give your full importance to model analysis. Okay, I've talked about a lot and in a much detail in our advanced courses. Okay, the entire why we should consider the eigenvector, where we should consider rate analysis, where we should go for mass participation factor. Now earlier someone was asking, sir, what about the mass participation factors and XYZ things? Okay, so this is the model analysis where we give full importance to mass participations. So it is very important that 90 to 95% mass of your building take part in model parts, model shakings. So if your building is not taking part, like if the mass participation factor for your building is like 30%, 40%, 50%, then this mode like mode 1 or mode 2 or mode 3 is only receiving 30% or 40% mass participation. then this model shape will not correctly be representing the actual shaking of this building. Okay, so it is very important that the entire sum of model masses of these individual modes, at the end the sum should be at least equal to 90% or greater than 90%. Then only these shapes will correctly respond or resemble to the final complex shaking of this building. Okay, if your model analysis is not able to grasp 90 to 95% of your seismic weight of the building, then this model analysis have failed. It is not correct. So it is very important that this model analysis, mathematical model, is able to grasp 90 to 95% of your seismic weight of your building. Then only the results of this model analysis will be applicable, will be factual, will be correct, will be practical on your building. Then only you can interpret the results from your response spectrum methods. If a building is not receiving 90 to 95%, then there is something wrong with the modeling and many other things which I have talked about in the advanced courses. Okay, here you can see these are the results of model analysis. Here you can the complex rotations, the complex rotation of one part, one wing, left wing, right wing. The right wing is moving more, rotating more, displacing more. Here you can see this corner is displacing less, this corner is displacing more, even this corner is also displacing more. This entire complex vibrational data, the entire complex shape that this building is taking. Here you can see during the rotation, this part is rotating less, this part is rotating more. This part is rotating less, this part is rotating more. This the information of rotation, translations, complex shapes, complex vibrational shapes that this building will take can only be calculated through model analysis. Without model analysis, you won't be able to see these results. Okay, this is the first rotation mode, this is the second X translational modes, this is the third Y translational modes. Whosoever is thinking that the first mode should not be rotational, then unfortunately welcome to the practical world of engineering. If your building shape is complex, you will not be able to completely eliminate the rotation mode from the first mode. Okay, books are ideal, this is the real field. This is the actual building that has been constructed on field. So you will be designing in advanced courses from the actual building plans. You will be able to see the actual building plan as well. The first mode will definitely come around a rotation. The second mode will be X translational. The third mode will be Y translational. Okay, so the main improvements that you can do is you can reduce the part of this mode. You can reduce the contribution of this rotation mode to some extent. Okay, you have to make several structural changes that we have talked about in our advanced courses. It takes time. Okay, if your first mode is rotational mode, then at least 1 to 2 hours, at least 1 to 2 days you will be giving to your structural model to reduce the rotational part. Okay, the contribution of rotational mode to the first mode. We have talked about this in our advanced courses. So through this webinar, you are able to see actual buildings, actual complex buildings, how these are designed. And if you are receiving rotational mode as the first mode, then there is no way you should panic. Okay, by any method, like, okay, if you are receiving rotational mode as first mode, then there is no way you should panic. There is no point of panicking, because this is a complex plan, because there is a eccentricity between center of mass and center of rigidity. If you apply a force from the earthquake direction, it will rotate. The basic first nature of this building is to rotate. So I have talked about more about this in our advanced courses. There are many factors. You have to look at the forces as well. If you have forces in under control, then you can go with the rotation motors as well. Okay, if your forces are under in control, then first mode as rotation is also acceptable. And there are several improvement techniques through which you can reduce the contribution of this rotation parts to the first mode. Okay. Steep slopes, Adikit. Yeah, for steep slopes it's very necessary. There will be soft stories. Either place X braces, K braces, V braces, or plan for shear model. You have to place shear walls. Okay. Yeah, Rohit is asking what is the difference between eigen and RIDS. We have to, it will take a lot of time to discuss about eigen and RIDS. You have to like shift to the advanced courses for that, but through eigen method is a simple method basically, which will give you the overall response of the building. But if there is a small parts which are individually placed in your building, like an antenna on the building, like a small 3-4 columns that are just erected for architectural purpose, they are free flowing elements along the height or the width of the building, then it is better to go for its analysis as compared to eigen method. Eigen method will give you wrong results. Much more in detail in your advanced courses. Yeah, Akshar is asking which value should I consider displacement values from time history response. The ultimate king is time history method. If you are performing time history method, which we'll see in a minute, if you are performing time history method accurately, then 100% time history method, period. Okay, this is the ultimate method. Nobody can win from this method, which we'll see you in a minute. Very interesting results from time history. Yes, Akshar, we have done the torsional irregularity check as well in this advanced courses. Okay. Excel sheets has been used to perform and calculate the torsional irregularity of this building, and it has passed the torsional irregularity check. So it is a very interesting format that like your building is passing in the torsional irregularity check, still the first mode is rotational mode. It is a very interesting concept following that you can learn from these advanced courses in this practical content. Okay, Chris Roy is asking how to register for advanced courses. Okay, you can register from advanced courses. It is released. Okay, it is live. Like if you learn, if you go to the fieldReady website, and then you can go to the main website. Here you can see we have released the advanced courses for. Okay, this advanced courses will be including Etabs 2023. RCDC software, SAFE software, CSI detailer software, and this advanced wind tunnel dynamic wind analysis software as well, Autodesk CFD, which will be taking a webinar on this as well in the next week or so. Okay. Now for existing mega course students or fieldReady students, you don't have to pay 7,500. You only have to pay 4,995. So when you will log in into your ID, the student ID, automatically this value will be reduced. Okay, so we are doing all the beam column structural models, practical loads. We will be providing you the Excel sheets as well. There are several layers of dead loads that you will apply. The water load calculation sheets will be providing to you. Actual dynamic lift loads will be applied. Okay, the moving, if the lift is moving, how you are going to calculate the forces. That is also taught in this advanced courses. Earthquake introduction, static. Okay, we are performing equivalent static method so that we can get the value of base shear. Okay, there is a concept of scaling that I will be teaching in this webinar. All base shear has to be around this equivalent static method base shear. So this is why we are doing equivalent static method analysis. Then these response spectrum analysis methods, then we are comparing the base shears. We are scaling response spectrum time history equivalent phases to equivalent static method. The entire time history methods has been, the files will also be provided to you. The wind force static has been calculated with Excel sheets. Wind force dynamic including gust factor is also included. We will be providing the Excel sheet, complete Excel sheet. If you are interested, then you can go with this wind dynamic forces. Virtual wind tunnel test will be performed. Virtual wind tunnel test will be performed in this course. You will be able to flow wind onto your building. Like you can see, this is a very complex building, very complex shape. You will be able to see how wind flows around this building in a virtual wind tunnel test, and you will be able to collect CP, CV values, pressure coefficient values, internal pressure coefficient values, externals, and the entire force generated, the moments generated at the bottom of this building. Okay, that has been discussed, that has been calculated in this wind tunnel test. We will be talking a little about the cost of actual wind tunnel test and which companies you can refer. That has also been taught in these courses. Advanced load combination, it is again a very advanced methods we have used here. The load combinations for this building will not be simple. Okay, if you are thinking simple earthquake, wind, this 1.5 and 1.2 will work here, then I'm sorry, it will not work here. So through this advanced course you will learn, like if you shift to the Etabs model, and if you look at the load combinations that we have formed, very large number of load combinations we have formed. We have used SRS methods as well, square root of sum of squares. So you will be learning about these as well in the advanced courses. So if you are thinking of designing buildings which are complex in shape, whose columns are not lying either in x-axis or y-axis, any building whose columns are aligned to the x or y-axis, then the load combinations will be different. So you will be learning those in this course as well. Advanced analysis complete. In design we have performed now. In this course we have done the manual checks as well. So you will be getting the manual sheet for column design, shear walls, beams, and the entire manual calculation has been performed as per IS code 456, 1893 and ductile checks as well. Okay, so you will be doing the ductile checks as well. CSI detailer is also included in this course. Again the RCDC, game changer. Let me know how many of you use RCDC software for detailing purpose. For detailing purpose. Yes, Akram Ali, gust factor will be calculated through Excel sheets and it will be applied in Etabs model. You will be learning in this course. Let me know how many students have worked a little bit on RCDC software and how many students are in a thought process or in a dream process that CSI detailer software will help you. Usual, it is very necessary that you now shift to the RCDC software for design and detailing purpose. Arnav, it is very important. Christy Roy, it is very important that you now shift to RCDC software. The CSI detailer software, which was earlierly detached from 2016, after 2016, Etabs 2017, 19 and 20, they have separated the detailing part from the main Etabs software. Now again from this latest around 1 week or so, they have released the latest version of Etabs software. They have again added that CSI detail into the main software. So now onwards CSI detailer software will not be a separate entity. It will be a by default part of the Etabs main software. That is the new information that I am giving to you. But as I am a practical engineer, I give actual design sheets to my clients. We are designing rough foundations, complex shape plans, oblique shape plans. There are shear walls, there are columns. There is a huge time that is given. It is taken in detailing process. So the CSI, unfortunately, let me break the myth about it. CSI detailer software will not be able to help you in this much. I have talked a separate lecture I have provided in the advanced courses. We have talked about the results, the design sheets provided by the CSI detailer software. So you will be able to see that it is not of much use to us. So let's shift to the, we are shifting a little bit. Give me 2 to 3 minutes to explain these courses. As Roy has asked about these courses. If you shift to the RCDC software, here you can see with few clicks you were able to import the entire beam column plan, the very complex entire beam column plan into RCDC software. Let me tell you that as of now, for design and detailing purpose, this is the best software that you should rely on. This is the best software that you should rely on, because first of all, the designing process, the inputs that this software is taking is very close to what IS codes are recommending. So you will be able to check the design results as well. We have there is an entire course that we have provided here for RCDC, column design, shear walls design. We talk about the calculation sheets as well. Not only how to provide the parameters, the actual design parameters. You can see the complex column plan was imported with few clicks. With very few clicks. Okay. The entire how you give input to these values, even every single value has been discussed. Every single tick and untick will entirely change your design sheets and entire results on your practical field. But let me tell you that this RCDC design software team has done a very good job in case of RCDC software for designing and detailing purpose. The detailing sheets are very detailed. If I talk about the detailing sheets, here you can see for shear wall, it has provided the entire lapping, the bars, the section sheets, shear rings. This is actual. You can directly provide this design sheet to your clients. I have checked it, I have calculated it again and again. The results are very, very accurate. And it is as per Indian sheets. What problem with Etabs software is that Etabs is very good at modeling. Okay, Etabs software is very good at modeling complex shapes plans. Etabs software is very good at analyzing the building complex shape buildings. So from now onwards, you should use Etabs for modeling, load application and analysis purpose. Okay, for analysis, for calculation of forces, moments, response spectrum analysis, dynamic analysis, time history analysis. But for design is very particular to India. It is done as per Indian codes. As this is American software, it is not able to grasp all the concepts and deliver it in a very convincing, very practical detailing sheets as this RCDC software is capable of. So this team has done a very good job in providing this. I've talked about a lot in the advanced courses, how we came up with these values, how we are giving these bars, how these shearings are performed, how these are calculated, can you change these shearings. Here you can see the entire BBS. This is the actual practical BBS that you are seeing, which you can directly give to your clients. At the end you can see what is the quantity of steel that this entire shear wall from foundation to the actual top level, 2 ton of steel, 2.02. And what is the weight of 8 mm, 10 mm, 12 mm, 16 mm bars. Here you can see I have used FE550. This is a TMT bar. You can see the shear shapes, shear rings calculations as well. You can export, okay, you can export this entire BBS to Excel sheets as well. If you want to do manual calculations, you can do that manual calculations as well. Okay, the entire lap. One also thing, if you are going for a BBS bar bending schedule, then lapping is very important. If you are ignoring the lapping part, then the entire calculation of steel quantity is wrong. What RCDC software is doing, giving you the alternate lapping as well. It is taking the lapping calculation as well. How to take lapping calculation, how to provide it alternately, we have taught in advanced courses. So you can actual practical, most practical design and detailing software that you can come across. It is a lifesaver for structural engineers, civil engineers. Here you can see for column as well. The entire section is formed, the entire detailing sections, the entire lapping is provided. Here you can see at the mid part, this is the beam, this is the top floor beam, this is the middle part, the lapping is provided in alternate fashion. And this lapping is not only provided for, like, if I tell you, let's generate a report, detailing report. like for a column C1. Like for column C1, let me go for elevation, basically elevation C1. See how quickly this is detailed for us. Here you can see the lapping. Here you can see in the section the corner part of the column are receiving 16 mm bar. The middle part are receiving 12 mm bar. So lapping for 16 mm will be different, and for lapping for 12 mm will be different. So it has mentioned the lapping for 16 mm separately and for 12 mm separately. Ring shapes are also included. And this is a practical ring shape. I have talked about a lot in our advanced courses how this software is arriving at a triangular shape ring shape. So this is a practical part, economical and practical part that is this software is providing. It is a complete game changer. The software for detailing, for design and detailing is a complete game changer. In a very few seconds, let me take to you. The way we used to design columns, shear walls was to check the moment capacity. If many of you would have remembered. This cutting length is also included. You can provide parameters for cutting length as well. Okay, Ujjwal? Okay, Barnat is saying that what about if you are buying a new laptop, most of engineers are confused. If you are buying a new laptop, you should go for 8 GB of RAM minimum. Either i5 or Ryzen CPUs you can take. Okay, and minimum of 2 GB or 4 GB of graphic card is required, dedicated graphic part, not a graphic part which is a part of the CPU itself. Okay, so it is very important. Minimum 8 GB RAM, Windows 10 or higher. Okay, Suraj, the theoretical aspect that you have learned in your college itself, the basic design of columns, beams, slabs, staircase has been discussed in this course itself. We are doing the manual checks as well. Like if you can see this building is a very complex shaped building. But in this building as also we have performed the manual calculations, and when we have verified the results from Etabs as well as in the RCDC software also. Okay, so this time in this course you will be able to do the manual calculation checks as well. This will give you a confidence, the understanding of how these elements are designed. So some part of your manual calculations will be picked from college. The additional parts will be 1893 complex formulas and including ductile detailing code 13920. Beam column capacity ratio check, joint shear check will be doing in RCDC software as well. So take this RCDC software to a very important level. You should consider this software for design and detailing purpose. It is providing us a very accurate good results for design purpose as well as detailing sheets that can be directly used. So RCDC software can be used for column design, beam design. Here you can see this is the entire column design. This is the sheet that we get. Column design, entire beam design. You can design the water tank as well. This is a very complex shape water tank if you can see in this model. I have designed this water tank, very complex water tank in RCDC software, which is included in the advanced courses as well. So you can design isolated footings, combined footings as well. But for rough foundation, we have to shift for safe software, which has been covered in this course as well. If you shift to this safe software, and slab design also in safe software. Okay, dynamic wind forces is also included. The entire virtual design you will be doing. More on this in future webinars, but the entire process has been divided in the courses itself. Let's switch to our webinar back. Let me answer a few questions. For Tongti, pardon me if I am not able to tell your name, Tongti. Okay, what about STAAD Pro? Any confusion about it? Okay, for modeling, detailing, load application, analysis part of dynamic earthquake forces, always go for Etabs software. For design, detailing purpose, actual practical bar bending schedule sheets, detailing sheets, shear rings, actual practical calculation of amount of steel, amount of concrete, amount of shuttering, then you should go for RCDC software. So model, apply loads, analyze your building in Etabs software, the simple Etabs software, no matter how the complex plan is. Then transfer your files to RCDC software for design and detailing purpose, so that you can receive this complex shape. Here you can see, if you go for any, let me switch to this. If you tell your draftsman to form these sheets for you, it's going to take 4 to 5 days. It's going to take 4 to 5 days for you to make these results. You are getting these results, very practical, accurate results. Nothing comes from thin air in RCDC software. Let me tell you that nothing comes from thin air. Everything is well calculated as per IS codes. It is strictly following as per IS codes. When you will switch to this advanced courses, you will see I have given an entire separate lecture to this calculation sheets provided by RCDC software. So we are referring back to IS codes as well. We are confirming either it is providing the correct result or not. Even in the detailing sheet, I have done back calculations, because I have designed many real world projects for my clients when your buildings are under construction, when your buildings have completed. So I have a very fair idea of what works on the field, what not works on the field. What is not working on the field, it has not been included in the RCDC software itself. Okay, this is very important. Suraj, what you are saying, in this course we have done both. Yes, in advanced courses we have done Etabs, RCDC software, CSI detailer software as well, and then safe software, and then the entire design part of it. The entire building, you will not be stuck anywhere. So any of the students who is listening me, if you have not taken part in the Etabs mega course, basically the mega course will give you the entire design cycle, the perspective of entire design cycle. If you are designing a building G+2, G+3, majority of what you will get in your early design career, then mega course is what you should go for. You will be learning the architectural part as per Vastu, placement of columns, structural modeling in Etabs, foundation design and STEAD foundation software. Then you will be learning to detail in Revit softwares and so on and so forth, and 3D Max for 3D modeling. So it will give you a perspective of entire design process. This is very important for a college pass out student or a student who has worked on a site, civil engineering site, who is not having a practical exposure to the entire design cycle. Without a design cycle, you will not be able to give design sheets to your client. You will be merely a puppet of either a senior structural engineer of yours or either a senior architectural structural engineer of yours. Architect engineer basically. So through mega course you learn the entire design cycle. After that you will be able to give the entire process. Now after this, if you want to learn the actual concepts of dynamic forces, the actual way we design high-rise buildings, like in recent course they are giving like you should not go for equivalent static methods. Many of softwares have also changed during this time period. The RCDC software has touched the next level in design and detailing process. The sheets provided is a much practical sheets that it is providing. So the game has also changed a little bit in these few years of pandemic after pandemic. The entire software companies have changed the process of it. So you want to learn the higher concept of it. If you want to design buildings G+5, 10, 15, 20, 30, 40, then this is the course you can go for. The concepts that you will learn in advanced courses after mega course, it will be a next level. Yeah, Arnab, after login, basically you should log out. Anyone, if you want to see the advanced courses, first you need to log out, visit the main website. Okay, Arnab is saying he is not able to see this. First log out from your web. Okay, if you are logged into your account, log out, then visit the main website. Here is the advanced courses. Click on the advanced courses. Now you can log in to see the actual price difference of 4,995. This is where you can see the advanced courses. Okay. This offer is only for existing students, not for other students who are not part of mega course and any course part of it. So if you are a new student, first you should go for mega course, then you should go for advanced courses. Advanced courses are for a very novice, amateur, young engineer who has a very little exposure to practical design field, the entire design cycle. Mega course is the best course. I have trained a lot of engineers. Many of them have converted into their they have opened their own design consultancy. We will meet to these students in the future webinars as well. You will be able to see their offices as well. Okay, and many of students have applied in MNC companies. They have got jobs, because it is very important that if you have the practical knowledge of using these softwares, entering data and entering value is a very easy task, and it is an illogical, I would say, nonsense task that you can see on YouTube. There are many lectures on YouTube. You have to have a clear understanding why you're inputting this value, why you're taking this load. Is this load really acting on this field, actual practical building? And what are the results? Are these results accurate? How I will be able to apply those results on field? Then at the end, detailing sheets. Does the detailing sheets make sense? The CSI detailer sheets will not make any sense to you. Okay, you will learn in the advanced courses, but the RCDC software detailing sheets is a game changer. I have applied it, I have used it many of times. So you will be learning the entire RCDC software, how to input values. Even a single tick and untick will make a huge difference. So the entire practical part, how can you use it, RCDC sheets has also been taught in these courses. For international payments, like MaxMed is asking for us, you can put a mail to support@fieldready.co.in. They will provide you a separate international payment link. Okay, from that you can make the payments if you are from outside India. Okay. Arnav, Suraj. Yeah, Suraj is asking each lecture is how many minutes. Minutes will not define this advanced courses. Okay, even during many of lectures, you will feel that even for within 1 to 2 minutes of this lecture, I will be able to give so much information that you have to stop that lecture and you have to go into deep analysis of like half an hour. So it will be that compressed information that you will be getting even in 15 minutes, 20 minutes or one lectures. Most of the lectures will be about like 40 minutes, 50 minutes. Okay, so it entirely depends on the part of either you modeling, designing, analysis, detailing, manual calculations. Manual calculations lectures will be lengthier. Complex model analysis will be lengthier. Okay, this is how it will be. Sheikh Zafar, installing software. Actually, first method you should try for installing software is through going for student versions. Ask their sales teams, CSI sales team, Bentley sales teams, and the other companies that are providing Autodesk, in case of it, if they are able to provide you the 1-year student access. Otherwise, if you are not financially capable of opting that software, then you can go with YouTube. Everything is available on YouTube. If and only if you are financially not able to buy this software as of now. But if you enter into the practical field, if you are able to earn from it, then you have to buy those software. We have bought those softwares. Okay, as an educational institute, it is mandatory for us to buy those softwares. Okay. Okay, back to over this. Too much talk about these courses. Let's back to our webinar. Okay. You understood the model analysis is very important if you want to actually grasp the actual behavior of this building during an earthquake event. Okay, the entire dynamic force methods rely on model analysis. If your model analysis is not accurate, then everything will make no sense. These results will make no sense. If your scaling is not proper, here you can see base shear. For equivalent static method, base shear, for response spectrum method, we have scaled it properly. After that, these results will make sense. After proper scaling, after proper model analysis, your sum of model shapes should be participating 90% of seismic weight of this building. So after all these checks, this graph will make sense. Now I can say that it is very necessary for me to go for response spectrum analysis method, as the force distribution along the height of the building is wrongly reported by equivalent static method. Here you can see. So after proper scaling, after doing proper model analysis, which is a game changer, then you can rely on these results that you are talking about. Then only you can transfer your Etabs analysis results to RCDC software. Then only this design sheets, the design results, the reinforcements will make sense. Okay. This is a practical part. Most of I've seen many of online frauds are also going on. Many of students are reporting me that I started fieldReady in 2017 April month. Okay, I've given a lot of courses, especially the mega course, which was complete design cycle. Then I shifted for a few years during the pandemic time. I shifted towards practical modeling, and there were a lot of practical demand from the industry, from the clients of mine. So after that, I put after certain time in the recent years, especially this like 6 months or 1 year, I'm getting a lot of calls from my students that there is online frauds going on. They are taking 1 lakh, 2 lakh, 2.5 lakh. They are putting EMI options on us. And later on, if I do not like the course, then I cannot cancel that EMI option. So this is a very big no. Okay, let me increase my size. This is a very important information that I'm giving you. You do not need to buy the fieldReady courses for this. I'm not promoting this one, that buy fieldReady courses, but you should avoid paying higher amount in online courses like 50,000, 25,000, 1 lakh, 2 lakh. Especially do not enter into a large sum of EMI options. If you do not like the courses, then you will not be able to cancel that EMI. At bank, people will come to your home and they will extract that money from you. There are a lot of reviews for several different companies that students have given. You can read the reviews as well. Okay, so avoid getting into a large EMI options. Okay, online courses does not require a physical class, so there is no point in giving money for like more than 10,000 or 15,000. Okay, the sum of 1 lakh, 2 lakh, especially the EMI option is very dangerous, because the EMI is processed through banks, and these courses are processed by these individual companies, individual coaching institutes. Once you start that EMI process, you won't be able to cancel that EMI process. No matter if you like the courses, whatever happens to you, even if you are not able to financially provide that cost to this. Okay. Okay, Suraj. Yes, especially that for offline classes, 40-50,000 is also very less amount. They will not be able to provide practical knowledge what you will be getting in this online courses. Okay, clear this thing in your mind that I'm a practical engineer. If I'm sharing a practical knowledge with you, the practical knowledge through which I earn on field, lakhs of money I earn from on field. If I'm sharing, then I'm increasing the competition in the market for myself as well. But fortunately, my financial condition are stable, touch wood, and the problems that I faced in college, I gave 4 years to my college, and I didn't got a practical knowledge. India is at a very different stage right now. We have a very youthful country right now. If you provide practical knowledge to these engineers, first there will be no joblessness. Right of now, if there is an opening in my company, and if a student from fieldReady comes to the interview, he will be able to perform, he will be able to model complex structures in Etabs. He will be able to do dynamic analysis in Etabs as compared to the college pass out students or site engineers who directly go to the site engineer jobs. He will not be able to even open those softwares. He will not be able to give me a conclusive, meaningful answer why he is picking this value, why the dead load is this much, why a response spectrum analysis is giving this much data, why you have used this shear links in these columns, how you are going to operate this software, does your result make sense? Even I have seen many engineers they don't even know the name of Etabs software. Many college students as of now are not able to recall, they are not knowing the name of the software itself. This is a very dangerous situation in Indian country. So looking at this situation, I said, "Ye to nahi chalega bhai. I am an action taker. I will change the situation." And I have changed the situation. Like around 2017 I started, there was very little chatter about the Etabs software in the market. Many of you would remember, if you are my old students, majority of design consultancies were used to STED software. I was the one who popularized the Etabs software, especially for modeling analysis parts. Still for design and detailing, RCDC software is leading. Okay, so this is the way we are going to change. These online courses are going to change. This is how you're going to get practical knowledge. Okay. Suraj, I do not charge much software. Okay, I can easily charge like 25,000, 50,000 for this advanced course. Like I can share you. It takes a lot of practice. It takes a lot of energy to formulate these courses. Okay, let me ask for some sheets that I have formed. Let me call my assistant. He will bring the actual scripts that I have written. Nothing comes from thin air in this advanced courses. Okay. Hello. Yeah, Ankit, bring that my scripts for advanced courses from the bottom of this. Okay. It is on the printer in my older room. Okay. Bring it on. Yeah, Ujjwal, mega course has helped a lot of students from 2017 till 2023. As of till date, I'm replying to my students, I'm talking to my students, and I'm starting a new thing as well now. Every month I'm going to take live doubt session as well. I'm going to take live sessions as well for doubt sessions. Okay, so whatever my doubts you're having through mega courses or through advanced courses, thank you. So see, this is how much it takes to. Nothing's come from thin air. This is a practical field. You have to learn, you have to write, then only you can provide data to your students. It takes time. It takes practical learning. It is a book, actually. This course is actually a book that I have written. And you will enjoy it. Like 4,000 or 5,000, 6,000 is nothing. You even buy a phone like 10,000, 15,000, 20,000. If you are little serious about, if you are given 4 years to your college and you want to understand how structures are designed practically, then this is the course you can go for. And I will be conducting doubt sessions as well, even for mega course students or advanced course students. Every month we will be conducting live doubt sessions as well. So this we can help you a lot. Okay. Someone was saying 1 lakh, 2 lakh. Yeah, usual mega courses have helped a lot of students, and on daily basis I reply to these students as well. So I'm solving the doubts as well. Okay. So I will be keep on changing the systems. Okay. If you think that I do not believe that India is lesser than any other country. And mark my words, this is the time that history is rewritten. That game is changing for India, the entire India. We have a very high amount of youthfulness in our country. There are a lot of youth. If you train this youth to practical applications, the industry standards, this is what I am doing through these courses. I am preparing them from industry standards. College are not preparing them. College are only providing the basics of it, the degree of it. But I cannot sit at home, or I cannot sit with the fact that a lot of lakhs of engineers pass out every year in civil engineering in India, and they are lacking this very basic knowledge that they should have before clearing the college. So many of IIT Guwahati students, I visited to IIT Bombay as well. I have taken a seminar at IIT Bombay as well. In future webinars I will discuss that as well. So there, the third year student, the fourth year students are getting exposure for these courses. This is a life changing. So for interviews we will be requiring this knowledge as well. Hand calculations are not going to help. Okay. Let me, some of the students are saying, kindly sir provide lifetime access to these courses. These are lengthy courses actually. They are very expensive to host on servers. The server costs are very heavy. So as of now we are providing one year access to these advanced courses. But I cannot promise, but I can say that in future if everything goes well and the financial situations of these online courses are decent enough, then we can increase the size of 1 year to 2 year or 3 year. But as of now, 1 year is definitely what you will get, and in future if everything is going very well, there are a lot of students, so we can be about some profitability, so that we can see the expenses of the servers. Servers are very expensive to host on video, especially videos. Yes, there is an offer for old students, Akhilesh. The actual amount of advanced courses is 7,500. For existing students, it will be 4,995 only. Existing students. New students are not given this offer, unfortunately, right now. So I have to be somewhat amount of loyal to my old students. So I have already promised them. So it will be a difference for a certain amount of time. Okay, now let's shift back to our webinar. It is getting very lengthy. You have seen the model, the charisma of model analysis. Now what steps you should need to follow? A very quick overview I am giving. It is a very dense and complex and very lengthy process that we can learn into the advanced courses. But for response spectrum analysis, first you have to define the spectrum function, the spectral curve that I was talking about. Okay, either it is your site is soft soil, medium soil, hard soil, all the details will be, or the entire curve will be formed as per that data. Spectral curve is the game. Response spectrum, without a response spectrum, curve is nothing. You have to define that into the Etabs software. And model case and model shapes, yes, model analysis setup is important. I've already told. Spectrum curve and model analysis data, very important. Then define load cases for response spectrum. Yes, load case has to be defined. Okay, if I let me give you a little glimpse about it, what I'm talking about. Functions you have to define. You have to define model cases as well. Then you have to define the actual force that will be applicable. Using that function, this force will be applicable. Here you can see the model analysis has been used. So how we came up with this scale factor, how we are arriving, why we are taking eigenvectors, why are taking with this function, how we arrived at this function, what are the parameters. Okay, design eccentricity is what we have to give. You can see overrides has been provided, very detailed concept. You would not have been seen in any lectures on YouTube. This is a practical situation that we have to provide. We will talk about more about it. Okay, eccentricities, IS codes, as per IS codes. So it is a very practical, purposeful, detailed, very satisfying course. If you give time and your energy to it, it will definitely change your entire design career. Okay, so this is how we have to define these forces. Then model analysis is also important. Then the entire load application will be done by Etabs itself. Okay, in STAAD Pro software you have to apply the loads, but in Etabs you don't have to apply the loads. Just have to define the loads properly. It will be automatically applied on the entire structural part. We have to run the analysis, dynamic base shears. We have to scale the forces. I've already told you. The entire scaling process will be taught in this course. Here you can see scaling. Scaling is very important. Why we perform this scaling has also been taught. So why? Why we are going to this equivalent static method base shear values? Why we cannot take directly what response spectrum forces are reporting to us? It is a very conceptual thing, very interesting and very conceptual thing that I have taught in this course. So we cannot simply go with blindly giving it a ratio or something. There has to be a reason why we are scaling it to this base shear. Okay, that has been taught in this course. Here you can see the spectrum functions, force definitions, then scaling part, then this whole final design part. Okay, then only you can compare these results. For this complex building, it has been performed. Here you can see if you can extrude this, is the entire complex part of it. We will be talking a lot about wall-like columns as well. Okay. Advanced courses you will be see wall-like columns. These are not normal columns. These are wall-like columns. This is not a normal column beam setup. This beam, this beam, this beam, this beam, entirely offsetted, not lying at the centers. What are the concepts? Why should we go for secondary beams? You will be able to see, someone was asking for secondary beams, how to form secondary beams, X, Y, Z as well. Here you can see secondary beams. There is a lot of miscalculations. Wait for a second. Hello. What is not visible? Okay. Oh, okay. I'm sorry. Oh, sir, I'm sorry. Slides are not visible. Okay. Thank you, Ankit, for these recommendations. I was busy in. Okay. Now the slides will be visible. Okay. Now the slides will be visible. Sorry for that part. Now again, the response spectrum. The people who are not able to see it, the model cases has to be defined. Forces has to be applied. Okay. Let me again go through it. Define load cases. I have defined the functions, very important, as per your site condition. So you will be forming this function as per your site condition. Okay. Then you will be applying the loads. The model cases will be setting. Response spectrum cases will be setting. This is the force actually which will be automatically applied by Etabs on this entire structure. Here you can see the response spectrum. Why we have taken this model analysis, what is the concept behind eigen, why we have taken eccentricity in this building, from where these results came in. Every part of it has been explained in this course. So the results you will be getting after this analysis will be actual practical results. Okay, this is what I am telling you. Spectrum functions, model analysis, actual forces, scaling part, actual results. Now let's shift to our. Okay, now everything is visible. Okay. Now the time history method. Here in this result, we were able to get the concept why we are shifting to response spectrum method. It is taking the dynamic nature problem to a static problem. So whatever you are applying in response spectrum analysis also is a pseudo dynamic analysis. Other name for response spectrum is pseudo analysis, because we are converting this entire earthquake, the entire ground motion data into simple spectrum curve. So we are picking the maximum peak values. Here you can see This ground motion data gave this peak, this ground motion data gave this peak, this, the entire time period of it. Time period for building 0.5, 1, 0.53, 5C. So you can directly pick these peak forces. But in actual practice, the entire structure will not receive peak forces at the same time. So the results outputted from response spectrum analysis also needs corrections. So if you are interested in knowing the actual responses of building, like shear forces, bending moments, the complex shapes that this building will take, through the entire vibrational data of this. So what you will see in this video, I will play it in a short minute. This is the Bhuj earthquake that I have taken. Here you will see live how the forces are generating at each time interval at 0.1 second, 0.1, 0.2, 0.3, 1, 2, 3, 4. Here you can see the seconds of it. So in response spectrum, we were picking the peaks of these forces. But in actual practice, the forces experienced by building will not be peak for every part of the structure. Here you can see best example of it. From positive direction, if earthquake force is acting, the shear forces are developed like this along the building height. From the negative side, it is different. So this nature cannot be acquired by response spectrum analysis method. Time history will give you all the dynamic data of a building, real dynamic data of that building. Okay, let me play this video. Focus on this. This graph will be vibration data will be taking, the actions will be taken, the actual ground motion data for Bhuj earthquake has been taken here. So once I will be playing this video, we'll be able to see this will move. The forces will be reported by this Etabs software here, the actual dynamic forces, and the actual dynamic activity of this building will be displayed here. How the building is shaking. And if you focus on this, you will be able to see. Okay, let me play this. Here you can see the ground motion is taking place. Displacement, drift, shear values is changing. The actual building is shaking. This is how the actual building will shake during an earthquake event. Let me play it again. During this part, you can see the building is shaking more rigorously. The bottom part is not shaking much, the top part is shaking much more. This is the real dynamic. Let me give you another information as well. I have applied the ground motion data for X direction, Y direction simultaneously. So you will be able to see the actual vibrational behavior of building as if the actual earthquake force has taken place on it. Like if you applied the ground motion from X direction, apply the ground motion from Y direction, then the resultant actual earthquake force will be acting on this building. So you will be able to see the actual vibrational behavior of this building, vibrational forces, quantities that will be developed if Bhuj earthquake hits this building as it hit it in this Kutch area of this Gujarat. So time history method will report all the force quantities, displacement quantities, bending moment quantities as per the time at each time interval. So at each time interval, if you are getting the actual force quantities, then the actual dynamic behavior of the building is depicted. Now we have the full control. Now we know how the building is responding to actual ground motion forces. So if your building is above G plus 10 or G plus 12 or 15, especially I will say G plus 15 or 20, more than that, or it is in complex shape, like if you can see this building is having a complex shape, then you should definitely go for time history forces. Then only you will be able to depict the final actual vibrational behavior of this building, vibrational forces. So as response spectrum method will be reporting peak values, and we know that the entire building is not getting peak values at the same time. Okay, it is different for different time period intervals. So actual time history will be able to tell you the forces experienced by these different elements of this building, like columns at ground floor, columns at G plus 6 floor, 10th floor. The story is different here, you can see. Positive direction, negative directions. Because the configuration of building is so complex, If a force hits from X direction and if it hits from a Y direction, it is different. And if it hits this building from negative Y direction, then it is different. Why am I saying this? X direction and negative direction is different for this building. Why so? Because the shear walls for lift, this is the service lift, this is a passenger lift. So the force hitting from X direction and force hitting from negative X direction will have a different effect on this building. Okay, that is why you are able to see this much changes. So time history method is very important if you are designing buildings about G+12 or G+15. I have performed this time history analysis for this building in this course. So let's shift to this basic, very interesting photo, like very interesting photographs that you will be able to see. What? This is a manual physical seismograph results reported by Meteorological Department Office of Pune for Ahmedabad station. At that time also you can see epicenter is in Kutch. This is reported by 21-22 July 1956. Just apart, few years apart of our independence, there were manual physical seismographs which were recording the data. At that time also Kutch area was giving us signals that this area is active in the earthquake. Here you can see at 21:15 time interval, here you can see the actual ground motion data. Sudden peaking and then relaxing. Here you can see also when there was no electricity, it was mentioned in this graph. General problem of less electricity. Very important, very important. From 1956, from manual recording of earthquake forces, we have come to this part where you can see the actual seismographs has been placed in the entire country that can report you about the earthquake events within few seconds. Within few seconds. This gives a clear picture that this part is active, this part is active. Very clear. Here you can see a seismograph has been placed in Bhuj. You can visit that office address as well if you want to. But you shouldn't visit, okay? If I am saying you shouldn't visit, they won't allow you without any reference. Okay? Masonry buildings are not safe. Okay, Sheikh? Sir, how many floors is safe for masonry wall construction? No safe. Nothing. Masonry is not safe. Masonry is very economical to construct, but it is not safe. Okay? This is the practical thing that I am sharing with you. So even that into 1956, the Kutch area was very active. It was reporting earthquake forces, the ground motion data was recorded, and then later on this happened. The Ahmedabad station, okay, if you can, the Ahmedabad station recorded this ground motion of Kutch earthquake area. At the time, Ahmedabad was having that. Later on, it was placed in Bhuj as well, but earlier it was having in Ahmedabad. Okay, so they shifted from Ahmedabad to Bhuj. This ground motion data station. At that time, it was having in Ahmedabad. Okay, here is the complete. I have taken this ground motion data in these courses as well. This is how this file is reported. So you will be learning from where you can pick practical Indian soil data. Very important. Next concept also very important. If you are taking an earthquake ground motion data of Turkey, then it is not useful to your buildings which are built in India. A lot of geographical, soil, tectonic plates, fault lines, lot of information is being holded in this vibrational data. So it is very important that you take vibrational data for Indian earthquakes. And any earthquake data is available around your site area, then it is the best. Because that ground motion data will have information about the fault lines, the amount of earthquake, the way the earthquake behaves, waves that dissipates energies, the amount of soil information that this vibrational data will be having in it will be very valuable. So all these seismographs are recording this data, and if you go for high-rise buildings, you can request this department for vibrational data as well. Okay, if you are designing building in New Delhi, then there are a lot of recording stations that you can request vibrational data. Then you can combine those 3-4 vibrational data into one, which you will learn in the advanced courses. Okay, so if you are designing building in Rajkot, then you can take data from Bhuj, then this one, this Bhavnagar. Then you can combine those data. Now this area, now the ground motion data, now the ground motion data that you have taken will make sense to these buildings that you are building in this area. If you are taking the building area like many of El Centro earthquake, I have seen many of students take for time history El Centro earthquake. This earthquake didn't take place in your land. It is not holding any information about your soil, about your geographical knowledge, geographical situation of that area. Earthquake ground motion data of this area and this area will be very different. The Nepal will be very different. Here you can see still the Nepal is active. So it is very important to take data as per the around surroundings. This is a very advanced concept that I am teaching you practically. Okay. So I have taken the Bhuj data for this. Now, once you have the vibrational ground motion data, then you can import it into Etabs, and then you can form spectrum curves for this ground motion data as well. Okay, Etabs will report automatically spectrum curves as well. This ground motion data will be applied on the structure. Now scaling function is also applicable in time history method as well. In time history we say it in a different way, spectral matching. Okay, in time history we are doing spectral matching. Now as I was designing this building for zone 2, the Bhuj earthquake is not clearly applicable to my site. Okay, I was designing a building for zone 2. I was designing this building for zone 2, but the Bhuj data earthquake is for zone 5. The amount of energies, the amount of forces, the amount of acceleration is as per zone 5. But if I want to apply this Bhuj earthquake, want to see the reaction of this building, then I have to scale down these forces to zone 2 values. So here you can see my site spectrum curve was like this. This was the demand by my site building. This is the demand, this is the forces that Bhuj earthquake is producing. So I have to scale down these values. I have to use spectral matching. Fortunately, Etabs software provide automatically this. Okay, you can do that. How to perform spectral matching will be taught in advanced courses as well. So now you can see the actual graph, the actual Bhuj earthquake ground motion data has been scaled down so that it makes sense to this building which is lying in zone 2. Okay, if this kind of earthquake takes place, then the responses developed by this ground motion data according to zone 2 will be like this. Okay, this is actual spectral matching that you can see. The gray line is for the original spectral curve, response spectrum curve for this building lying in zone 2, and this is the actual Bhuj earthquake response curve that has been scaled down to match with the original spectral curve. Much more detailed talks will be done in the advanced courses. Okay, here you can see through this we were able to generate this actual response of this building. You can see the shaking which is taking place around the peak time of this. Initially it was nothing, then suddenly there were peaks, sudden shaking was there, then it is settled down with the time. It is a building lying in zone 2, so there is not much of higher shakings that you are not able to see. Slight shakings, but these are real shakings, the actual response of this building that you will be receiving. So this is how we perform practical time history analysis on our buildings. If you are taking El Centro earthquake ground motion data, then you're just doing nothing to your structures. This is not applicable to you. The best method I have already explained to you. It is better if you're designing building for this, take data from these stations. request to this National Center of Seismology department, they will provide to you. If you're designing buildings like Jodhpur, then you have to take in surrounding data. If you're designing for Delhi, then you have to take surrounding data. If you're designing for like Assam, Guwahati, Shillong, then you have to take this data. Guwahati, IIT Guwahati is there, so they are having a seismograph here as well. Okay, I have many students from IIT Guwahati as well. IIT Bombay, IIT Delhi. Okay, NIT students are also there. They are in constant touch. Okay, I performed a seminar as well in IIT Bombay. I will share the pics with you. So it is very important that you take data from the surrounding stations. This is a very practical information that I'm giving you. Okay, gone are the days now you will be using the El Centro earthquake for this data. Okay, gone are the days then you will be using El Centro earthquake data. This is the how practically you design time history method. Lot of steps, lot of methods will be taught in advanced courses. Let's shift to the final sheet. Now the holy grail of this, equivalent static method versus response spectrum method versus time history method. Proper scalings has been done, and here you can see time history method, the yellow curve, blue curve is for equivalent static method, the orange curve is for response spectrum method, and yellow curve is for time history method. Even the time history method is giving us a lot of more information, the actual dynamic behavior. Like for lower stories, the building is depicting results more towards the equivalent static method. But for middle stories like G+6, G+10 stories, actually the building is receiving less forces compared to response spectrum method as well as. Okay, equivalent static method is very overestimation of the forces that this building is receiving. So if you think this is the major factor why we are not relying on equivalent static method, is that the force, the actual forces that it is applying on the building is as per cubical equations, this parabolic equations basically, but the actual dynamic behavior will be very random, which will be formulated by model analysis. Game changer. This model analysis only can tell what shapes this building will take, and if you are calculating forces at each time interval, then you will get exact curve. Okay, we were taking peak forces, so RSM method was not able to predict the actual shape to the exact time event that is we're taking. Okay, so time history you can calculate the actual forces. This is the actual forces this building will be receiving during if a less amount of Bhuj earthquake is acting on this building as per zone 2. This is part of mega course. We have actually prepared this Excel sheets and course itself. We have taken the results from Etabs software after the analysis of this building, and then we have copy pasted the results and then we have compared it. So we have actually formed these graphs. Okay, so this is how practically you should learn. Okay, this is how practically let me shift this to this limit. Okay, so this is how practically you should learn. If you're not learning practically, then there is no point of it. You can put any number into response spectrum analysis methods. There are many videos on YouTube, but if you are not getting the actual grasp of this concept, why we are using it, why we are leaving this equivalent static method behind, what is the reason? This is the reason. It is over predicting the forces. Why we are relying on time history method for buildings above G+12 or G+15? Because of this. Because time history method, the yellow line, is able to predict the shape, the forces more accurately compared to the orange line, which is for response spectrum analysis method. Okay, this is the practical part of it. And time history forces also, you cannot take any ground motion whichever you like, and you cannot directly take the forces based on the reported by Etabs directly. You have to do spectral matching as well. Okay, If your ground motion data is as per the zone 2 or zone 3, and if you're designing that building for zone 5, then you have to do upside spectral matching. And if it is a zone 5 data, and if you're designing, if you want to see the responses of building for zone 2 area, then spectral down matching. That has been taught in the courses itself. Okay. This is how structural design is done. This is how the core concepts, the understanding of young civil engineers of India, the college pass out students should have already in their mind. Then only they can think of overtaking the developed countries. We have the full potential. We Indian people have the full potential to take over the world. We have the young youth as well. We are only lacking the practical part of it. The colleges are not teaching those practical parts because those professors, especially those curriculums, especially not the professors, the curriculums especially are based on old teaching. Industry exposure is very less, and none of those industry professionals is ready to share this amount of knowledge with students. You won't be able to see this amount of knowledge, this amount of understanding, this amount of graphs. This is the first time you might be seeing most of the students. This way how this equivalent static method, response spectrum method, time history method has been explained. This is the practical result. Now your mind is convinced why I should leave equivalent static method, where we can use response spectrum method like G+5, G+12, G+15 till that. But if my building plan is very complex and I'm interested in knowing the exact dynamic behavior, then time history method is the way. The data that we'll be taking, the scaling we will be doing. Now the things make sense. Okay. Now let's see. I've already told much about the new course list, so I won't be talking much about it. I provided basically, let me provide the link to you if you want to enroll into this courses. Direct link. Okay. Make sure that you are logged out to access this page. Okay. Once you're logged out, then only click on this link and then you can log in again. Okay. Much more in detail. Now the doubt sessions. As this is taking a lot of time, we will be concluding in a minute. Okay. Let me take the doubt sessions. Yes, member, honorary member. Okay, honorary member firms do not train freshers as well. Let me shift this data to this and let me give me a second. Okay, let me shift to something else. Minimize will not do the job. This will do the job. Okay. Now I can read the chats as well. Okay. Yeah. On remember, firms do not train freshers as well. They ask for ready-made 3 years experience. This is why I've released this course. The same thing I experienced in my field. Same thing. Nobody was ready to take us, but I hustled. And I hustled a lot. Now I'm at the point where I'm designing G+6, G+10, G+12 buildings easily. Now we are in my firm is in a process of taking a large scale projects as well. G+60, G+70 we are working on it. We are taking it. So more focus on Mumbai, Delhi parts as well. Okay, so their wind forces overtake the earthquake forces. So there is that is why I have included dynamic virtual wind tunnel test on this building as well in this course. Okay, so you will be learning that part as well as in the advanced courses. So Mumbai, Delhi buildings are more controlled by wind forces rather than I'm talking about wind and the wind is blowing. A large wind bubble is forming around. Okay, sir, should we calculate scale factor for response spectrum method? Take default values. Definitely, you have to calculate response spectrum scale factors. Definitely. Then there will be no sense of your data reported by Etabs if you're not scaling it properly. Much more has been talked about in the courses while scaling the properties, okay? Because this response spectrum done by default Etabs, by default Etab method will not be applicable to your building if you're not scaling it up. Sir, what would upload response spectrum and time series? Sir, when will you upload response? It is already in the advanced courses. As softwares and many methods have changed, and we are shifting to RCDC software as well, so you can find it in advanced courses. Conventional is avoid conventional methods for high-rise buildings. Which method of construction is best in earthquake-prone areas? Earthquake-prone areas, always go with response spectrum method analysis or time history method analysis, RCC structures. No conventional structure should be built in zone 4 or 5, especially in the east part of India or the northern part of like Jammu and Kashmir, also very active area. Jammu and Kashmir active area is also very active. If you can see here you can see Jammu and Kashmir area is also very active. This region is also very active right now, okay? So even the earthquake took place here, we were able to feel the jolts, so very slight jolts in Jodhpur, Jaipur, and Rajasthan area as well, many Delhi areas as well. This is a very large distance. Usually earthquake effect dies around 250 or 300 kilometer area, okay, but it was felt very large. That means the entire area between this zone is fractured. It is in a very unstable equilibrium stage. That is why a single jolt is experienced through such large distance. So globally something is very weird going on in terms of earthquake. The entire plates are responding, giving a very forceful responsive reactions right now. The entire plates are very active, okay? Turkey was very unfortunate, a lot of people died, but I think unfortunately India might be the next. India might be the next. Very unfortunate events will take place because this area, entire area, 80 to 90% buildings are conventional, like not an RCC building even as well. And most of the RCC buildings are soft storage. So if you're not going to retrofit these buildings, then there will be a lot of people who will die, unfortunately. And Delhi, do not forget, capital city, large ministers, large forces, every large higher common people are sitting over there, and it is very close to this region. 3.2 crore people. I cannot imagine what will happen if an earthquake of 7 or 8 magnitude will hit then New Delhi. Very unfortunate events will take place. Okay, always avoid conventional methods, go for RCC building, okay, when seismically active areas, 3rd zone, 4th zone, 5th zone, always. Scale factor is important. Conventional I've talked. Okay, Roy, you are talking about cracks basically. Let me tell you all the students, I have not talked about secondary beams. Okay, I won't be talking about because it will take a lot of time, but I will give you a glimpse of it. Let me tell you one more practical thing, very important. Listen, you all. Okay, if you are releasing the moments at the end of secondary beams, like this secondary beam, then you're doing a wrong thing. Let me break a myth of yours that I have taught about in this advanced courses. If you are releasing the moments at the end of secondary beams, then you're doing wrong to your structure than right things. I practically explained this concept in our advanced courses. Why shouldn't release? And one thing, Jumla, that is going on YouTube and around every structural engineer, you should use stiffness modifiers. You should use stiffness modifiers, like reduce the strength of beam columns to 30%, 40%. and then design your structures, then analyze your structures and perform. Let me tell you, there is no need of stiffness modifiers. I'm giving you practical knowledge about it. There is no need of stiffness modifiers. Okay? So there is a logic why IS code has provided you one line that you should use stiffness modifiers, and then you have to blindly follow, you have to provide stiffness modifier. There are situations where you provide stiffness modifiers to particular areas, and the logic should make sense that I have taught about in these courses. I have used stiffness modifiers in these courses, but from practical point of view. Much more about this in actual courses. The entire building never go for stiffness modifiers. Okay, your client will die. Okay, they will climb to a higher building and they will die if you are designing your building from stiffness modifiers. Like you're reducing the strength of columns 30%, your beams to 75%. You can think amount of steel you will be receiving 3 times, 4 times, 5 times. Your client will die. Or I'm exaggerating this situation, but your client will not accept your designs, and it is not even practical. And there is a very reason for not going for the entire structure stiffness modifications. Okay, there is a reason behind it. You will be learning that in the advanced courses. So releasing the moments at the end of secondary beams and using stiffness modifiers, there is a huge myth which most of the engineers are not aware of. I practically with Etabs results have talked about all these secondary beam moment releases and this stiffness modifier situations in this course. So how to practically use it, you will be learning in this course. Long-term, short-term cracking has also been taught in these courses, okay, of slabs. Crack analysis of beams and columns has also been done in RCDC software. That has also been taught, okay. I want to know if you take sound vibrations into consideration, because sometimes I have seen sound. Okay, Rahul. Yes, if your building is very close to railway stations, if your building is very close to airports, then you can take that sound vibrations into account. But that vibration is also then recorded by a device seismograph. Vibrations basically. Then that vibrational data that you have to import into Etabs, and then you have to apply that vibrational data on Etabs structural model. So that way you can design it. Okay. Okay, I think now we can conclude this live session. We will be conducting a wind webinar as well. Virtual wind tunnel test, dynamic wind forces, gust factors and not. This has been taught in very advanced courses, and we will be conducting doubt sessions as well for mega course students and advanced course students as well on each month basis. This will be live. You just have to report your doubts early, and then I will be able to answer to each one of you through live sessions. Okay, so now the journey for the webinars, many webinars will be conducted on per month basis. Doubt sessions will be conducted on fieldReady platform. Okay, so stay tuned. So let me know how you like this about these courses. You learned a lot from this webinar. You learned few new things through this webinars. Yes, concept has been taught. Webinar, Weber, weak beam, strong column, that we in logical terms we talk about beam column capacity ratio check, that has been performed in Etabs and RCDC software as well. Okay, the manual calculations has also been done. Let me tell you that as well. You'll be practically learning why we are going for this. Okay guys, from now I have to just close this webinar. It was very interesting. It was after a long time I came on webinar. I will be conducting on daily basis, on monthly basis basically, and do keep in contact from the WhatsApps through emails. We will be releasing more webinars. If you're interested students who want to go for advanced courses, then you can go for this. I have provided the link. Okay, you can go for these courses as well. Okay, and For doubt sessions, we will be conducting live doubt sessions as well. Thank you. Okay, now we'll be closing this webinar. Have a nice